And I want to welcome everyone to this workshop on ambulatory assessments. We're going to be starting this morning with a 45-minute presentation just on the approach to ambulatory assessment. But I do want to let you know that there is a link in the chat for an activity that we'll do in the second talk. We'll put that link again up in the chat towards the end of the session so you can get into the activity at the time that you're going to do it much closer. We're going to be talking today about ambulatory assessment, which is measurement in a natural context. It's what you're doing when you walk around and you're doing what you do. That's basically the idea behind ambulatory assessment. It's capturing people in the natural environment and trying to look at what daily life is like as it's lived, not as it's remembered or as it's looking at the experience objectively as well. It's measuring what's actually happening to people. You can include the subjective experiences, we'll see, but it's much more of an observational study, if you will. And has tremendous ecological validity because it's done in the natural context. There are several types of assessments. We won't talk about all of them. We'll talk a little bit about the Actical, which is like a really super good Fitbit. It measures things very precisely. And the way I think about it is that if you think about that, we can measure where a satellite is in space, we can measure movement very, very precisely. So with my Fitbit, I can do this. And if I don't put it on in the right spot, it'll capture all kinds of movement that isn't there. The Actical is much more precise. We can look at physiological responses, cardiac monitors. We're going to talk about that in just a few minutes. There are apps, there are sensors, looking at things like skin conductance, anything that's happening to the body in that moment physiologically, we can look at. We can look at the location. Where are people relative to their environment? And we're going to look at that later on this morning. That can be through GPS, through smart home. I didn't put here some of the other ways that you can measure that. You can measure environmental inputs, things like pollution. Sensors do that. There are all kinds of sensors. This afternoon, we're going to talk about the electronically activated recorder, which captures sound in the environment. And you can actually track what someone's doing throughout the day by video. And so Kristen Grauman in our Department of Computer Science has designed like this headband with a camera, and it's obviously far too much information. How are you going to look at 24 hours or even 15 hours of the video? So she's developed algorithms that look at what they looked at the most. And so you might use that to remind an Alzheimer's patient of what they did that day relatively. I do know she's had some trouble testing it because she tried to test it on college students and they all look at their screens most of the day. So there's not a whole lot of variability, but these are some of the things you can do. The main one that you probably are familiar with and that you will probably want to include is the EMA, the experience in the moment subjectively. Because as social scientists, we aren't just going to observe, we want to know what the person was thinking, what they think they were feeling. The subjective experience is key for most of the things we want to understand. And so that's a major part of it, is these handheld devices with subjective surveys. There's several questions you have to answer before you get started that I just want to mention. This is sort of the common, how do I do this? And what do I do with that little handheld device? Well, you have to think about what platform to use. And so the iOS on your iPhone is not the same as the Android program. And the other thing that you need to know is that these are not interchangeable in terms of what you can do on them. Your handheld device is not a little computer. It's not necessarily using two apps in synchrony. It could be switching between the two. So there are things you have to think about. One platform might be better than the other in these contexts. The other thing you need to think about is whether you want to use a common device. So for older adults, this may be much more important. I'll show you that in a moment than it is for younger adults, because younger adults are going to want their own phone maybe. If you are going to have a baseline survey, which is not uncommon, you have to think about how you're going to transfer that information from the baseline to your small device in the program. So for example, in our program, we ask people who's most important to them, And then on the handheld device, we asked if they've been with that partner and what happened subjectively. And we had to have a macro to download that information into the program. With older adults, you have to think about size of font. And this isn't just a matter of, okay, we'll just, click on it to make it a bigger font. You have to think about the question you're asking and the amount of space it's going to take up on that phone, because you want that screen. You don't want them to have to scroll on a screen. You also have to think of the ease of a touch screen, that if people have arthritis or have some kinds of issues, they're going to need to have a stylus, or you're going to need to design it so that it's not this little precise box they have to do. So there are a lot of things to think about just on this, which is, there are all kinds of now commercially available. You can do it on Qualtrics. You can do it on a lot of different kinds of made for this kind of survey software. But you do need to think about this. When we did our study, we actually worked with the company, and they and their computer programmers and ours got together to design what we needed for. And I think Liz Munoz is going to talk about some of that process this afternoon. This research is always done with a multidisciplinary team, I would say, pretty much always. I haven't seen it, commonly done without that. We think of multidisciplinary as a demographer with a psychologist, with a statistician. Maybe you're doing some biomarkers, you're getting spit throughout the day or whatever. You've got your biomarker expert. And then maybe you have some content experts, right? You're putting this into NIH. You're saying, look, I've got 3 people who do nothing but study caregivers. I've got my spit person. I got someone who can analyze these data with the spit and everything else. And then I've got me as a psychologist and, Deb Umberson as a demographer. And that's my multidisciplinary team. In this work, you probably are going to want a computer scientist involved, and not necessarily involved the whole way through, but you're going to probably consult with one. So you're going to get to know your computer science department if you don't already. You're going to, interestingly, okay, so I was working with sound waves using the device and information that Matthias is going to talk about that he has designed. And we had 150,000 files. And so we looked at how long that would take to transcribe. We did it over like a couple months and then did calculations, and it was going to take 5 years at the rate we were going. So we were going to have to do this differently. And we wanted to get rid of anything with silence. We don't need the silent files. We're not going to analyze those beyond knowing they're silent. And so I contacted the computer science department and said, who can write me a little program to find the silence? And they said, oh, that's not us. You need the computer scientists in the Department of Music. So I went to the Department of Music, and because they do MP3s, they have the computer programs. So now I'm collaborating with someone in the Department of Music who actually said, don't program it yourself. There's software you can use that they use in the recording industry, and you can find the silence. It took a little bit of human grad student effort to do that because they visualize it, but we checked and it was 0.3% difference in using that. It was much, much quicker. So you're going to be maybe with the music department. I have worked with people in urban planning. I've worked with people because they knew how to do GIS coding in a different way. I know Kara has worked with people in engineering and technology. So it's going to be probably an interdisciplinary team that's very potentially different from who you've already worked with. I've worked with a computational linguist as well to look at some of the data from Matthias's device. So all of that, just be prepared, get to network, you'll find the people you need, but you're going to need to do that. And now I want to just briefly talk about the pitfalls of technology in these designs. First of all, the ownership varies for most devices. This is just people over age 80, the smartphone, the tablet, the wearables, your Fitbit, your Alexa. The likelihood of owning it, 12% of people over 70. And if you're using that with someone with cognitive impairments, they forget Alexa's name, Andrea, whatever. So there's a lot with that smart home and things. The other thing, I just want to show this to you in a different format. If 86% own smartphones, 14% don't. Do use, do not use. Same thing here, you're up to a fifth, do not. And once you get over 70, you've got almost 40%. And once you get over 80 and 90, it's even fewer. And this is probably the sample you're most interested in. They have less education, they're more vulnerable, and they don't use this technology. And so you have got to train them in it. And that's a very key part. We got on one of our reviews for our NIH grant, How do we know you can do this in people over age 85 with low education? So we tested it. We were using an iPhone at that point. And what we discovered is not one of them returned both the little box and the cord. They had never seen anything like that. We ended up using the Android device in the actual study, but there's a lot to this if someone's never done it. You're going to touch the screen. Updates are your enemy, because when you have an update, everything slightly changes. And if you're working with people who've never used the device, that can be problematic. So we did not have ours on the web. We had no function for it to connect. We had it standardized, so there was only one program on it, and updates. Matthias and I could tell you some stories about updates that, it's always a lot of drama if there's updates that go on that hurt your pre-programmed app. So the question here is, I could go into a lot more, but I need to move along to Kara. The pitfalls, I think you're going to hear about today in numerous ways. It leaves you wondering, what's it good for? And the answer is pretty much absolutely everything. I don't know if you know that song, War Hum, what's it good for? Absolutely nothing. Absolutely everything on ambulatory assessments, even though it's kind of demanding. And I want to turn it over to Kara Burdett, who's going to talk about some of the cardiovascular measurements she's done. I'm going to stop screen share, Kara, so you can screen share. And you're muted, Kara. Kara, you're muted.
Okay. Just look. Can you guys see my slide? Okay. So today I'll talk a little bit about the ambulatory assessment of cardiovascular reactivity. And let's see. Why isn't it? Okay. I'll talk about why we collect ambulatory cardiovascular data in our program of research. I'll talk about the cardiovascular system and the stress response a little. I'll talk about the study design that we use when we incorporate cardiovascular assessments. And then I'll talk about the types of data that we get when we collect this data, and then how we merge it and the problems that we need to consider when merging. And then we'll talk about visualizing the data a little bit, and Karen's going to follow up with even more data visualization. So why do we assess cardiovascular reactivity? Well, we're often testing the biopsychosocial models of health. And this is just one example of a biopsychosocial model that we test in our research. We refer to as a biopsychosocial model of racial health inequities. And according to this model, personal characteristics like race and gender predict variations in stress exposure, which can be long-term or short-term, and social relations, which are also long-term or short-term. And then all of these predict short-term stress reactivity. And as Karen mentioned, we often look at stress reactivity in terms of psychological mood, in terms of positive and negative affect. We also look at behaviors in terms of health behaviors and coping. And then finally, we want to know about the biological systems that link the social environment with health. And we focus a lot on the cardiovascular system in our program of research. And the cardiovascular system in this case is measured by heart rate variability, and blood pressure. And today I'll talk about the heart rate and heart rate variability data. And all of these predict overall health. So just a little bit about the cardiovascular system and the stress response. The stress response, as you all know, is associated with activation of the cardiovascular system. And this predicts increased heart rate and then lower heart rate variability. And it's adaptive in the short term, but it's harmful if it's chronically activated. And there's research showing that greater cardiovascular reactivity over time predicts future cardiovascular disease. And heart rate, the normal resting heart rate is 60 to 100 beats per minute. And as many of you know, a lower resting heart rate is a sign of better health. And just to talk a little bit about heart rate variability, it refers to the variability in the time between the beats. And we often get heart rate variability when we assess cardiovascular outcomes. The top graph shows low HRV. So this has no variation in the time between the beats. It's 1 second every time. And this is associated with stress, poor emotion regulation, poor health, and poor sleep. And on the bottom graph, it shows high heart rate variability. So there's variation in the time between the beats. And this is associated with stress recovery, better emotion regulation, adaptability, and good health. And so often when you experience a stressor, you have higher heart rate and then a lower heart rate variability. But as you start to recover from that stress, your heart rate variability increases. So this is just one example of a study that we conducted called the Stress and Wellbeing in Everyday Life study. And in order to test biopsychosocial models, it's important to have data at multiple time scales. So for instance, this participant is the overall, the person has their baseline interview, which assesses things like stress, social network size, and demographics. And then that person has data over the on the day level, which could be sleep, coping, health behaviors. And then every 3 hours, we assess things like mood and number of social interactions and negative interactions. We also have assessments of events. So whenever the person is feeling stressed, we have them fill out a survey, what's happening right now? And I'm not going to talk about that data right now, but so you can have time interval types of surveys and event types of surveys get at different types of stress information. And then every 10 seconds, we have heart rate and heart rate variability. And every second, we have blood pressure. And I will focus on the heart rate and heart rate variability today. So to assess heart rate and heart rate variability, we use what's called the BodyGuardian Heart Monitor. And this has been updated since then. But when we started using it, it had 2 monitors, and the participant wears it for 12 hours. Wears one monitor for during the day for 12 hours, and then they take it off and put on another monitor at night. So they have 24 hours of potential, if they wore both monitors religiously, they would have 24 hours of data. And it assesses the raw ECG data. It's worn on the chest with a little sticker and buttons. And now it's even better. It's smaller, and there's just one device. So, and it's called the BodyGuardian Mini. If anybody's interested, they could ask me more about that. But it comes with a mobile phone, which is beneficial in some ways, but also really extremely irritating in others. So it's completely locked down for the BodyGuardian. So it is monitoring the data. So it collects all the ECG data and automatically puts it up to the web. So it's always connected to the 5G network. But to do the EMA surveys and the event surveys, we had to negotiate with the Preventus, which is the company, to unlock the phone to put on some of the EMA survey information. But the other problem is that those phones don't receive text messages. So we had to find software that provides a push notification with a link to the web, and then use a separate web survey software. In this case, we use Blaze, and now we're using Voxco. So there's all these different technological things to consider. So yeah, so then the data provided, you get the raw ECG, which I work with engineers, and they were really interested in that so that they could create their own scores. They think of heart rate and heart rate variability is way too basic, really. So they're really interested in analyzing the ECG and creating different types of scores. But for today, I'll talk about the company provides you a heart rate score and a heart rate variability score. And so this is, and you can always go, when you have participants, go up to the web and look at their data. And this has really been useful. You can see their ECG, you see their 24-hour heart rate. You also see whether there's missing data or errors in the data, which allows us to call the participants and either adjust the position of the device or put it back on or charge it, for example. And so we created this whole system for interviewers to check the data at 11 o'clock every morning, and then they mark down whether it has missing or unreliable data, and then they mark whether they should call the participant. And then even after we get the data, we clean it more. So we get rid of data that's out of range, and then data that looks unreliable. So the BodyGuardian provides a reliability statistic for every heart rate outcome, and you can select for the only reliable data. So I'll talk about the types of data now and how important it is to consider how to merge the data and structure it, which I'm sure many of you know because you've done repeated measures, but the heart rate and heart rate variability causes more drama. Here's baseline. So this is what you usually get when you do a interview with a participant. It's their sample ID, the date of the interview, and then their person level information. Oops. And then we get the EMA data, and that's in repeated format. So the person, this is the same person, 309, and then they get a line of data for every EMA they participate in, and you can see that the time of day that they did their survey, they don't necessarily do it right when they get the ding. So it's really important to know what time it happened so that you can match it with the heart rate and heart rate variability data. So here's just one participant on one day. They did 6 interviews. And it's important to note how the time is measured. So here, time is measured in military time and Eastern Standard, Eastern Daylight. And each variable refers to the last 3 hours. So in our surveys, we're asking people, what happened to you in the last 3 hours? So for instance, this second interview here, we said, how many people did you interact with? And they said they interacted with 3 people. So, but that refers to this time period. That's important to know. So then we get data from the Body Guardian, and this is at the 10-second level, and it's at a different time type of time. So this is in time. Time is in universal time coordinated and in AM/PM format. So this is important to understand. I had never had experience with universal time. It's basically 4 hours different from the time that we're used to over here, Eastern. And then we have heart rate data and variability data, and this is repeated for every person every 10 seconds. So we had to think a lot about how to merge all these data together to look at how baseline information and self-report every 3 hours is linked with heart rate and heart rate variability. And so you have to think about, first of all, how to merge it. And we transformed all of our time to Eastern Daylight Time, because this is in June, and military to merge the data. And then we had to think a lot about how to aggregate the heart rate and heart rate variability data. And of course, there's many, many, many ways to do this, but so far we've been looking at the median and the mean for heart rate and heart rate variability. So we just, and this takes a lot of time for my data analyst to do this, but she has to find the time that was 3 hours before using their EMA data and calculate the median and the mean heart rate for each time period. So then we get 6 lines of data with the median and the median, the mean and the median heart rate and heart rate variability. Other things that are important to remember is that daylight savings time changes everything. So you have to pay attention to the date that the surveys were done. And that participants don't necessarily do things when they get the ding, and they might do it after midnight. So we just, we adjust the clock because we use military time, we adjust it past the 24 hours. So for example, 1:30 a.m. is 25:30, so that you can make sure that that data is linked with the right day. And just to show you some examples of ways that we've looked at the data so far, this is the number of social interactions that participants had, and each line in the data, each line in the graph is a person, and a survey refers to which survey it was. So it was, they could do 24 surveys, and you can see here that there's a lot of variability in the number of social interactions that they had, that they reported in their 3-hour interviews. And here's the heart rate data, and this is the aggregated heart rate over time for each participant. So we've been thinking a lot about how to look at the data in terms of visualization and analysis. We usually use multi-level models to analyze the data, but it's also important to visualize it. And so one of the things we've been doing is creating these graphs that basically create a slope for each person. So this is a way to look at 2 variables at once. So those last ones were about each person in one variable. So this is each person and the link between the 2 variables, which is the number of social interactions and their heart rate. And you can see here, each line is a person, and it represents the association between social interactions and heart rate. And overall, having more social interactions is associated with increased heart rate, but that it varies a lot between participants. So and the strength of the color is the strength of the effect. So it's a larger a larger association with a stronger blue color. You can see some people don't show that link. And so this is important to know when doing multi-level models too, because you can see, are there some people that have a greater association between social interactions and the heart than others? For instance, they might find it more stressful to have social interactions. And that's, and Karen's going to talk more about visualizing. Lost. Oh, you're muted, Karen.
Here, just give me 1 second, Kara. I've still got, oh yeah, this is, okay, let me get to your, sorry, I was on the wrong slide. Okay, so here we go. Can you all see my slide in just that slide, not more?
Yeah.
Okay. We're going to talk for just a minute about putting it together in a way that also helps you understand the individual, because ultimately, this isn't about math, it's about a human being. And so trying to figure out what's going on in that human being at the same time, Kara just showed you, you can look at the coordination of how many social interactions they had and their heart rate. I'm just going to show you some other ways to think about this all. I'm going to be talking from the Daily Experiences and Wellbeing study that we did. And we had 333 adults over the age of 65. They did a 2-hour initial interview, and I mentioned that already. And we transferred that onto the EMA. They also wore a Fitbit. They did the AIR, the electronically activated recorder that you're going to hear about. And then they had some other things that we gathered on them. But I'm just going to talk about that Fitbit, the EMA for a moment. And what we were interested in is we were interested in whether the diversity of people they saw affected their physical activity and the number and types of activities they were doing. Because we thought that with intimate people, you could just sit at home and watch TV, right? You're with your spouse, you just sit there and there's very low activity, you're much more sedentary. But if you're going to see any kind of acquaintance, you at least have to get up out of your seat to open the door. And the difference between sedentary and non-sedentary is huge. Sedentary is a huge factor in mortality above and beyond your level of activity. So if you go to the gym at 6 in the morning and then you sit all day, that many sedentary periods is bad for you. That's part of the reason we're going to stop at 45 minutes so that you can get up and move every hour so we don't contribute to your risk on mortality. But in this study, we're interested in how active are they and how sedentary are they? And so we used the data from the ActiCal. Now we've got a whole bunch of things we're looking at. We want to know what's the diversity of their activity. We want to know how sedentary were they. We want to know how active were they, because like I said, those are actually independent measurements. We want to know how many activities they engaged in, because doing diverse activities is associated with better cognitive functioning on self-report measures. So when the Health and Retirement Survey asks people and they say, yeah, I do all these activities, those people are more cognitively intact, but we wanted to look at that in the social environment. Is it also a matter of interacting with more diverse people? Because there is also research that shows that on the whole, but we wanted to know something about the activities in the moment with the diverse people. So now we have a lot going on, and within an individual, all those things are happening at the same time. So we wanted to look within the individual, and I'm going to show you a visualization of an average participant. So we took someone who fit the sort of average on most of these variables to look at how they co-occur. And what we did here is this is the diversity of social engagement. Who were they interacting with? So your average participant in our study is still married. They're maybe only interacting with their spouse in the evening. These are also 3-hour intervals like Kara's. They're reporting their most diverse activities in here. So they're doing more different things. Everybody ate every single interval. And I suspect that if we did it during the pandemic, you'd find that you could probably track that every 10 minutes people ate. But when we look at percentage of time sedentary, here it's corresponding to the activity with different people. The social engagement that we predicted is in fact there. it's also there with diversity of activity. So if you're doing chores, you're doing the dishes, this is 4 o'clock to 7 o'clock, you're engaging with people, you're out of the house because you ran an errand, all of those things, you're also less sedentary. We had been focusing on the social, but the diversity of activities matters as well. Now, this is our ActiCal physical activity data. And what's interesting here is that the reviewers asked about lagged effects, right? So how do you know about the lags? So remembering that you're assessing right here on a 3-hour interval, did it predict what happened next? And interestingly, when you do the lagged, physical activity predicts social engagement, right? Because at 1 o'clock, you're really physically active and you're still really socially engaged until 4. So we get this lagged effect. We don't think it's causality. We think what happened is you are with these different diverse people. You're in your 80s and you're active here. And it's kind of hard to be that active for that long. So you're still pretty active here compared to here or here. But it looks causal when we believe it's co-occurring. And this is an interesting aspect of ambulatory assessment, is that arguing for causality becomes much more complicated when it's likely co-occurrence. And even on some of your key questions like stress and cardiovascular reactivity, remember that you have a human interpreting things. So as the heart rate goes up, that's associated with anxiety. And so just in that moment, yes, they had an input. Yes, it raised the cardiovascular, but the cardiovascular also is co-occurring. And it's really hard to argue one caused the other. The anxiety and heart rate may go up together because that's what emotion is it's subjective and physiological. And so we're really capturing something very differently when we look at how they co-occur. I'm going to turn it over to Kara for a moment because she's going to show you that co-occurrence. If you don't mind, Kara, I'll just keep on your slide. You can tell me when to stop. She's also going to show you some co-occurrence in hers.
Yeah, so I looked at Karen's visualization and I felt jealous. So I mean,
I feel jealous all the time of Kara's study design. So I'm not jealous. I just envy and wish I were you.
So I had my data analyst made this picture with not an average person, but just with that person I talked about earlier. So it's 309 on that same day. So you can see on that day how multiple variables are linked, not just 2 variables at a time or 1 variable. So the top is the number of social interactions. And remember, they had 3 on the those 3 time periods. And then they also reported whether those interactions were negative of the interactions that they had. And they only had 1 time period where they had, I think this is just refers to one negative interaction of the 3. And then they reported how tense and stressed they felt. And you can see here, this person is really calm. This is not at all tense or stressed, except for this 1 period where they had a little stress. And then I think this shows something similar to what Karen's talking about, is that it's co-occurring. So this is their heart rate data. Can you just like scooch it down a little bit, Karen?
I'm sorry, what do you want me to do?
Can you scooch it down so I can see the ECG?
Hold on, yeah, let me escape my, I stopped the screen share too. Hold on, sorry, Kara. What I'll do here is I'll screen share this. I'll screen share just from the slide. Okay, can everybody see that now? So you can see.
So can you just say share a slide as a presentation?
Yeah, I'll put that in presentation mode now. I'm not sure. Not sure I'm going to get you to where. I'll try slideshow. Okay, is that good?
Yeah, if you just like scroll down, there you go. So,
okay. Sorry, guys, okay, I'm not very good at this.
So this is the median heart rate in each 3-hour period. And this is their raw ECG data, or their heart rate over the 3-hour period. And then she did this line that represents the moving, the best fit line. But you can see here in between 12 and 9, they had a higher heart rate median. And I think that is showing that there's something about having more social interactions and negative interactions and feeling tense, stressed is associated with the heart rate, a higher heart rate. But there's a lot more we need to do. I think analytically, we need better skills in terms of how to combine all these data together. In terms of like, is there a latent variable, like just a crappy, stressful period, or I don't know. So it's interesting, but I think it shows that it's bidirectional.
Yeah, and I think that's really an important part of ambulatory assessment that's very unique to that. Because if you just do things on a 3-hour self-report, you may have things that appear as lagged effects when in fact they're co-occurring effects that have occurred amongst your events at the same time, or at least you can't disentangle realistically. You can mathematically, but you can't really make that argument. I think. Kara, do you have a?
Oh, it just reminds me of the cortisol findings that we've had, that higher cortisol in the morning often predicts more negative interactions. So it could, these things are bidirectional. So you might,
Yeah, that's a good point. Steve Zaret has a paper on something like anticipating an easier day, and the cortisol changes. These are caregivers. The cortisol changes in the morning before they get the extra care on days when they're getting extra like paid caregivers to come in because they're expecting it. Remembering that there's a subjective cognitive experience, that's what humans are. And that's what's interesting in many ways in these assessments. We were going to do a little Zoom, you visualize the data, but I don't want to run over. I want to give you a break so you're not sedentary. And I think we have about 7 minutes left. So instead, I was going to do this little thing and have you all do this just to visualize co-occurrence. So if you look at the 30-minute, you might have your camera off so you can eat and check your email. You might still post something in the chat because you're still listening. This is where you're logged on to Zoom the whole time. You still have your, camera off, and you didn't actually surf the web, but when you're in the breakout rooms, you might have the camera on at that point. So there's just a lot of ways to think about, again, the co-occurrence just of what's occurring in this meeting, where most of you have the camera off and you might be eating or chatting or I don't know what. We were going to do that visualization and have you do that just because I want to make the point too. If I were visualizing this, I would use a clock and I would have every 15 minutes just marked and put all the events in each quarter so I could see that occurring. You could do what Kara and I did in ours, but I think on a thing that's just 1 hour, I would try that just to see how it plays out and putting those activities in. You could think of a dozen different ways to visualize this. It's just helpful to do that, to look at the co-occurrence of events and just to get a feel for how that occurs. I do want to go over just the schedule briefly, but before I do that, why don't we take some questions? You're welcome to put them in the chat, and I'll stop share for a moment. What questions do you have on our stuff that we've done so far? Yes, Young, you want to ask something?
Yeah, so the visualization is so beautiful. I'm just wondering, when you submit your article for publication, do you present it like that, where you just present like one participant that way, and then like do you provide a table of coefficients that then captures the experiences of all participants in some way? I was just curious to see how you published those findings related to the visualization.
We did publish this in our paper, The Spice of Life, where we first showed this. So we did, and you'll see a lot of the spaghetti charts that they call them spaghetti charts that Kara showed. I think show up in a lot of articles, but we did put this in there, and they found it useful. I don't know, Kara, have you published with visualizations in yours, or Kate, have you?
Not yet. No, but I can see. I think I'd want to show the slopes for every person. I think is really interesting.
Okay. Yeah. So you don't have to do an average slope for everyone in the study. You just do it like kind of like that spaghetti plot that Kira showed earlier.
Yeah, I think there's a decision making there, and I think some of it is as this field evolves. So this is pretty early in terms of publishing. We published this in 2019, And so people weren't as familiar. Like in 1999, back in the olden days, I published a paper where we used hierarchical linear modeling, and I really, really had to give a tutorial because it was pretty new. And so I never would do that now. People know what the term means and things. And so I don't know that this would be something you would need to show in 5 years, but given the stage of the research on it, we did do that. We do have, yes, we definitely have tables that show the whole sample, that show the analyses, that, you know, we report the lagged effects. This is just an extra, if you will, but we do report all the standard data that would be expected.
So, sorry, go ahead.
Oh, the other thing I had, I noticed when even doing this, you know, preparing for the presentation, I had my analyst make another association graph, the slope one. And there was one person that had influenced the whole overall B, and we could see that by making the picture. And so I think that's another thing that really helps you see if there's some, you know, crazy outlier.
Mm-hmm. And, you know, Kara, you also mentioned you used Actical for the physical activity. Is that considered sort of the gold standard in the field for assessing physical activity, or is that like a moving target, like where things are changing all the time about what's considered the gold standard assessment tool to use?
I think it still is, in that it has so many more accelerometers in it than your Fitbit or your phone. And I can just tell you that now that I didn't have a Fitbit thing, and now that I do, I mean, just if I just move it to here for the day, I get all of these extra, I call them carrot points because they look like little carrots, but I get all of the super points way more easily than if I wear it like that. So, I mean, it's just so easy to trick it. And the Actical has a precision to it. But Kara, do you have I mean, you could also get that on the Guardian, I guess you could get things. There's other, but just using a Fitbit, I don't think will get you there yet.
Yeah, I haven't used, I mean, the Body Guardian does collect activity, but I haven't used that data yet.
Yeah, but I think the bottom line there is that you need a more precise instrument than, particularly because we're interested in something like sedentary, or just really in old age, just little bits of difference can make a difference. So we're, you know, yeah, right now, I know at the time I did this, it was definitely the gold standard. If we have any other questions, if not, I think I'm going to flip through just to the schedule for today. So we're going to take a 15-minute break, and then Kate Cagney will be talking about some really cutting edge, really interesting activity space. And if you would please check the chat and click now on this Google Doc, you can set up an account on the software and do a little survey during this break, which would be great. You can still do it. We'll put that in there again during her talk so that you could do it during our lunch break. We'll come back in the afternoon, and we're going to have just an amazing talk on cognition throughout the day, because we have an idea that cognition is a standard variable that you can just assess, and yet it may fluctuate as people go about daily life. And finally, Matthias Mill is going to talk to us about the electronically activated recorder. And there is a literature with that is really pretty amazing. And language is one of the key aspects of both cognition and social life. So it's that crossover. And you can really get some very interesting analysis of it. And he'll be talking more about it. And so let's go ahead and take a little break.
Karen and Kira, I really enjoyed your presentation, and there are lots of interesting synergies with our work. So I will look forward to your comments. Okay, I am going to start sharing, and let me know. Can we see my slide? Great. Okay, thank you all. And I just also want to say quickly, if you have questions as I'm speaking, you should feel free to jump in at any points. I often say I'm from the University of Chicago. I spent a lot of time with economists, and right, that is the mode here. So please jump in, and I hope it'll be conversational. And I'm actually from the Department of Sociology at the University of Chicago, and I, with David Meltzer, direct our Center Shibley, which is another center on the demography and economics of aging at the University of Chicago. And our hope is to bring together new methods and insights, particularly related to longitudinal data analysis. And there'll be kind of a longitudinal hook in what I discuss here today. Okay, so What do I want to do in these next 45 minutes? I'm not going to spend a lot of time on this, but I want to speak briefly about the underpinnings of research on place. And I want to argue for new ways of capturing place and noting that our ability to characterize place has changed considerably in even just the last 10 years. And then I want to ask how new approaches might bring insight into varied topics such as segregation, loneliness, and COVID-19 exposure. And I'm primarily using these as ways to show you, or maybe to best illustrate the challenges that come with some of this work, and to get your insights too. Okay, so on those challenges, I want to talk a little bit about the challenges and what I might characterize as opportunities that come from these new forms of data collection. What we do in the project that I will describe today is that we bring together GPS tracking and ecological momentary assessments so that we can situate people in space. Their emotional reactions, their descriptive assessments of the interior and exterior environment. I'm going to go into that in some detail. But I want, as we have this conversation today, to highlight some of the things that have been more challenging, how we've addressed those challenges, where we hope the science will go. So some of the things that off the top of your head, like what might matter when we think about GPS tracking? So certainly issues related to connectivity. Yeah, Karen mentioned this earlier, but updates. Updates are an interesting aspect of all of the work that we do. I'm going to talk a little about phone functionality. I'm going to talk about road snapping and our experience with road snapping. And I'm going to talk about what happens when one collects data more frequently, or the mechanisms do. And we want to be able to assess change over time. And I'm going to use COVID as one example, thinking about pre and post and how this is a particular challenge. And then, one of the other things, I'm not going to describe this in detail, but one of the key things one needs to think about, there are a lot of data here. So data management, storage, data cleaning, all of those issues. I then want to speak about the EMA component. And Karen did a really nice job, I think, illustrating, key contributions of ecological momentary assessment, but I'll show how we've kind of invoked it here. I liked Karen's slides that focused on, age and cohort differences, I might argue, in who has a smartphone. That mattered to us, and it meant we distributed phones, and we were focused more on a lower resource population. And so many of those individuals did not have a smartphone. All the issues Karen mentioned, these two of training, comfort, sight and dexterity, instrumentation and its influence. And I'll give you one example on that as we continue our conversation. And then, one of the things I want you to think about is, what's the right balance in terms of EMAs a day? I'll say in our study, we follow people for week-long periods and we ping them 5 times a day. And we've had a lot of discussions about whether 5 was optimal. So I'll be interested in your insights on that. And just wanting to note too, that I'm not sure whether you were able to look at our, that's our end of day survey. That's why it's called 5. I wanted you to see the questions that we ask at the end of the day, because I'm going to highlight a couple of those questions. So I wanted you to see that, but feel free to jump in. It takes about 10, 12 minutes now, later, whenever, just to see how we approach this work. And then
Kate, I am going to jump in, and gosh, it's amazing how much overlap there is. We didn't plan this. It's just amazing how much overlap there is. But I love the point that you made about storage, because you have to, I've never had to do that before. You have to calculate before you do the study how you're going to store it and how many bytes you have. And that was really, I forgot about that you have to figure out, like, we have an extra hard drive for this. Michigan was actually collecting the data, SRC, the Survey Research Center, and the final transfer of data took 36 hours. So you have to calculate all of that ahead of time. It's a really good point.
Yeah, so just kind of, having a certain, where we work with NORC, and so they have a lot of storage capacity, but it's just something one wants to kind of, keep in the realm of things, even when you're thinking about a budget for a grant, how you're going to make sure that you can store those data and you have the resources to do it. And the last thing too I'll mention is just, how we incentivize participation. we gave people we gave them, $70 for a baseline survey, and I'll describe that only briefly, and then $35 over the course of the week. We could talk about whether that was enough. I think at the time it was probably okay, but actually when I think about the kinds of burden that this particular sort of data collection enterprise kicks in, maybe we'd want to think about a larger number. Anyway, maybe that will come out as we continue our conversation. Why do these methods matter? And so I'm going to briefly say I think they matter because they align with theory. They speak to actual exposure space. So in the neighborhood effects and health literature, for instance, we rely a lot on the influence of the residential location. And we are all spending a lot of time in our residential locations at the moment. I'm clearly in my own home. So the residential location is quite influential right now, but I think it's important to think about the broader notion of exposure space. I think these methods situate emotional states in space, which I think is really interesting. We've been able to draw that out. And they allow us to engage in longitudinal data collection effort. So those are some of the things I wanted to highlight as key aspects that I think are novel. So let me just tell you a little bit about why I think this kind of approach syncs better with theory. So I take a sociological approach to understanding the impact of place, people in and across time, and the limitations in the characterization of space, both the breadth and the depth. So, one of the things I think is really interesting to think about is the circumference of turf. What is the place that we inhabit during our day, and how that microenvironment might matter. And those are the ways that we've not really been able to capture our space effectively. So the question is really whether new methods can provide insight into what place is, how it's perceived, how it matters for health, and potentially how it could be modified for an aging population. So sort of that arc of knowledge. So research on neighborhood effects and health. Just to briefly state that theoretical approaches largely neglect the actual spatial exposures beyond the residential address. As I noted, we often use census tracts as proxies. It would be interesting to know how many of us on this Zoom today can characterize the boundaries of our census tract, know where it is. So really to think more carefully about social disorganization theory that comes from a sort of old Chicago school sociological theory, Sean, McKay, Burgess, and others who help us think through the structural resources of community, how they link to particular social processes, and then how they might affect an outcome like health. We incorporate the conceptualization of individual level exposures. This is really this notion of activity space. Some of that is motivated through the work of Jane Jacobs. I don't know if any of you read Death and Life of Great American Cities, but this idea of a street being animated and how being embedded in that animated space could matter for lots of different kinds of outcomes, including health. But here today, I want to emphasize age and aging. So thinking about how the circumference of turf may shrink, but little is actually known about these patterns as one ages, and that neighborhoods and networks within may be more consequential. So I'm going to really take 1 minute on this, but thinking about these structural processes, how mechanisms link the structure to outcomes. We have lots of great theory to draw from. Casarda on networks, Rob Sampson, Steve Rodebush on collective efficacy, Scogin on disorder, all the ways that we think about how neighborhood social context matters for both neighborhood outcomes and individual outcomes. We then think about how, we look at a focal neighborhood, that's that bigger square in the middle, and we look at all these adjacent neighborhoods. How do we deal with that adjacency? So some of the methods I talk about today could help with that. We have some statistical processes. My colleague Luke Anselins helped us think about those spillover effects. But what I'm really interested in is this little neighborhood out here on the right. So how do we incorporate the influence of that space that one spends time in? And that's really, I think, a key contribution of the methods I'll describe here. So what do I mean by activity space? It's the set of places individuals come into contact with as a result of their routine activities. And I wanted to give a shout out. This is Activity Space, Social Interaction in Health and Later Life. This is our NIA grant, so thank you to NIA. This is our large research team from Newark, from Chicago, from Boston College, Cornell, and then we have this really terrific advisory board that's helped us think about the contributions of some of these methods and the ways in which we can enhance them. And so I will just say here, just as a setup, this is our, our specific aims for this project: multi-wave data, 450 Chicagoans. I'll show you the map of where they're drawn from in a moment, conducting in-person interviews to get some of the biological measures Karen mentioned earlier. We use a smartphone app over week-long periods to identify latitude and longitude, distance traveled, describe activity spaces, and obtain these real-time reports using EMA to identify day-to-day fluctuations. I'm not going to talk about this other piece today, but we do leverage extant information. The census, we have a project called Array of Things. My colleague Charlie Catlett is the PI. And what we do is link those data. So they're sensors across the city of Chicago. And Charlie allowed us to put those sensors in the neighborhoods where we were collecting data. So we also have environmental context data. It can tell us about wind, rain, but it also tells us about street activity because it takes a sweep of the block. So those are all the ways that we're combining lots of different data sources to enhance the way that we characterize how people inhabit space. And because this becomes important in a moment, I'm going to tell you a little bit about our NSF Rapid grant, a one-year grant. Like many other people, we had an ongoing data collection effort. We decided to extend it to understand COVID and again, the influence of space. And one of the reasons we thought this was, or hoped it could be a contribution, is that lower income persons, those who are racial ethnic minorities, those in economically disadvantaged neighborhoods, may exhibit routine patterns of exposure to more crowded or higher risk locations. So it was kind of trying to remove this kind of notion of individual risk factors for COVID to understand the context in which people are operating. So differences in social environments, activities, social integration may mean that it's they're engaging in spaces that are just riskier. Leisure activities in free public spaces, for instance, relying on crowded shopping destinations, depending on public transit, and maybe continuing to work beyond the retirement age, which means they may be in face-to-face service sector jobs. So that meant too that we applied these same methods we had developed in the larger, our larger activity space study, which we called CHART, Chicago Health and Activity Space in Real Time Study, and we have this COVID extension. So we did an intake survey, GPS tracking, and EMA over 3 waves. And one key thing we wanted to do was to compare pre and post COVID. That will be one of my example challenges that I'll discuss. But we wanted COVID experience with self and others, precautions, social interactions and compliance, and neighborhood perceptions. We also, this is just a side point, but for those of you who are interested, because of the time that we collected data, we did also incorporate perspectives on recent protests, street activity, police action, neighborhood perceptions. I won't emphasize that today, but wanted you to know that, that those data are available. So this is the structure of our study. So we saw activity space in the neighborhood as overlapping spaces, but not completely embedded. We did an in-person questionnaire, at baseline, all of these key characteristics that you can see. So we're really dividing these 4 components: the health questions, biomeasures. So we did blood spots and the like, our social environment questions, and then behavioral questions. We had baseline, wave 2, wave 3, followed what I call wave 4 are the COVID data, and there are 3 data collection efforts embedded in that. So our ecological momentary assessment, as I mentioned, we collected 5 times a day, real-time capture of variation. So with questions like pain, positive affect, social engagement, and I'll show you some examples of that in a moment. These are, I don't know how many of you are familiar with the city of Chicago, but these are our neighborhoods. There are 10 neighborhoods that we selected propulsively because we wanted variation by race and social class. As many of you likely know, the city of Chicago is quite segregated by both race and class. And so we had to be intentional about the neighborhoods where we drew sample. So as you can see here, there are neighborhoods that are African-American, primarily Latino, primarily white, and then those which is a smaller subset where we see more integration by both race and class, and then we sort of divided by high and low NSCS. And this is one of the first challenges I want to emphasize. So one of the things I want you to look at, so these are our 10 neighborhoods, and this is where people are moving, and these data are collapsed So this is, all of our respondents are moving in these neighborhood spaces. So you can kind of see where they originated and where they went. Sometimes I use this to kind of underscore the point that we may be, at least in the city of Chicago, segregated by race in terms of our residential location, but wow, we are also segregated in terms of where we spend time. And I think that's an important component of understanding how we think about race and social networks, social relations. I'm not going to emphasize so many of our substantive findings here today, but if you want to engage in substantive work, one thing that was interesting, so look at the density in wave 1. And then look at the density in wave 2. And then look at the density in wave 3. And what do you notice?
Can you go back again and just show us the 3 in order again?
Right, yeah. So that's wave 2. And that's wave 1.
Are they getting out more? I mean, the bottom right-hand corner seems to be increasing their...
So look at, well, okay. So they could be, but here's the problem. So in wave 1, there was initially a challenge with the way that MetricWire, which MetricWire does both our GPS and our EMA data collection. They had not done as much GPS data collection embedded in the EMA. So it turned out that there was a technical glitch with the way that the tracking interfaced with the actual infrastructure of the phone. And so we didn't notice it right away because we're thinking like, oh, you don't have any baseline, right? You don't know how much to anticipate that people are moving. So the data, we can still get sort of an expanse. We feel like the data for our standard deviation ellipse, and by that I mean the circumference of turf that people inhabit, will, that we can still characterize that, but the density of spaces, we are a bit limited in our first kind of data collection component of wave 1. We don't have as much data as we might like. So this is a good to know kind of thing, I think, for those of you who are collecting data of this form, that you really have to make sure that both that the phone infrastructure speaks well with that sort of data collection mechanisms that whoever your purveyor is develops. So this is something, again, that we sort of discovered by doing. So that's one of the first challenges. And again, we think we can well characterize the circumference, but didn't have the density. Here's another issue. Has anybody heard the term road snapping? Is that familiar at all? For those of you do GPS data collection. So this is this is one of our respondents. This is characterizing where he or she spends time. And this is kind of what we would expect those data to look like. And so that looks pretty reasonable, right? So what do you think of this? And what are you noticing that looks wrong?
They're driving?
They're not driving. Sorry.
Oh, it's a train.
No, it's a person. But what's happened is that person we think is doing what they were doing in that last image I showed you. But it's the signal is snapping to the road. Oh. And so this is how it characterizes their space. So we know where they are, but here's the thing, for older adults, I care whether they're inside or outside that house.
Right.
And so that it snaps, bad. This is bad for what we want to be able to get to. Now I can still tell that someone is sort of participating in social space, but I really want that precision of indoor and outdoor. So right now we are working with the MetricWire company to try to develop a way to sort out what this road snapping means. But it's frustrating, as you might imagine, because you've already collected the data. So to have some kind of post-assessment amendment to it, that's harder to develop. But this is just something to keep in mind as people might do this work and test it. two things happened in this context. One was that, and Karen, this is back on your point about the updating. So the science is moving so rapidly. And what I want is a steady state algorithm over my 3 waves of data collection, whether they be the 3 embedded waves within the COVID data collection or the 3 main waves in our chart study. I want to be able to compare over time. It's great that innovation exists and things are changing, but I don't want them to change this quickly. And so that was, another key challenge for us. And partly this comes with communication, right? And how you're working with the people you're contracting with to collect these data to say, please, I understand how you're innovating. Please flag that when it's happening so that we can make a decision.
Yeah, and that was definitely, I've never worked with the company designing things so much. Like, to personally know the people in there. Yeah, I think that's really a key part of it. The other thing, Kate, that I just want to make the point is also how, as the technology changes, your relationship with IRB and human ethics.
Exactly.
So when I first proposed my study, I got dinked at study section with, oh my God, how can you track people? And now it's just like, oh, sure, we're all being tracked all the time. Use what you know. So there's also that, as technology changes, its relationship with humans changes too.
Yeah, exactly. And I think how, our levels of comfort, how we feel about, these, right, there's certain sort of science, how people, I think, feel more comfortable now. We're being tracked in lots of other ways. I think we are all well aware, but how we have sufficient data protections so that we are not releasing these data in any way, right, where individuals could be identified. And so I think if people feel confident about that, that's great. I mentioned our Array of Things project earlier, where we do a sweep of a block. And one of the things that's so I work with computer scientists at Argonne National Labs, and one of the things they've been able to employ, which is really innovative, is they take a sweep of the block and then they analyze that image in situ. So they can tell whether it's a bike or a baby carriage, an adult or kid, and then they bring in those data. So we're not transmitting images. So I think as our science evolves, there are lots of ways that we can both get the sort of data we need, but also, right, be attentive to issues related to human subjects. And I'll just show you this because I think this is a key, it was a key challenge for us. So this is the summary of the 3 COVID waves. It shows tracks visited, total distance, that standard deviation ellipse I mentioned, which is really the circumference, number of active days, number of waves. We're looking at differences among race groups and between the poor and non-poor. But what I wanted to do was compare this COVID wave to our pre-COVID waves. And right now, I don't feel confident because of the change in the algorithm I mentioned and because of that challenge with the road snapping. And the road snapping only happened during our COVID waves. And so I'm still not able to compare. So I'll show you some data later where what we did was we relied on the EMA data collection to help us do some comparisons pre and post COVID. So I'm still able to characterize what's happening. But right now for our GPS data, I feel tentative about sharing those data because of the issues of the change in the algorithm and the road snapping. So let me take you to our EMA approach now. So I've showed you sort of what we do, how our GPS data collection works, and let me draw out now the EMA. So we did 5 beeps a day for 7 days, survey window, and hopefully we're able to at least work through a part of that survey wave 5. We ask what language you'd like to complete the survey in. When you were pinged, where were you, at home, at someone else's home, in transit, by bus, train, subway, and whether you were indoors or outdoors. So this comes in handy later when we're thinking about the COVID experience, right? Are people in or out? At the time, who are you with? So that gives us a characterization of the people they're actually embedded with. But separate from that, we want to know the other people who are around. And this, I'll show you one result related to the distinction between these 2 questions later. And then we do a lot of, kind of emotional state. Did you feel content? Did you feel like you had energy? My colleague, Erin York Cornwell, is really interested in how the space of a home takes on some of the same elements as a neighborhood space would. You know, so like what's the environment of the interior space? And that's particularly interesting for older adults. This came from some of her early dissertation work, and she's extended this. So that's why we've asked questions about whether that home is cramped or spacious. You know, does it feel close knit? That comes from old, you know, Chicago school theory and contemporary elaborations by people like Rob Sampson and Steve Raudenbush, and this notion of collective efficacy theory, the ability of the community to come together for the common good. So that's an example of one of those questions. And then on that point, one of the things we were able to do, and actually Rob is a consultant on this project, we wanted to apply collective efficacy theory, again, kind of components of so informal social control and social cohesion to places one passes through. And so our theory was you still kind of get a vibe of a neighborhood, even if you're not living in it. So we wanted to be able to modify those collective efficacy questions. This place feels close-knit. If I needed help, someone would come to my aid. But we also wanted to draw out positive and negative forms of local interaction. So we wanted to get, you know, are there people of different ages in the neighborhood, people of different races, smiling, nodding, saying hello, people helping one another? Because I think, you know, we all had a sense that sometimes some of the neighborhood-based work we engage in, we end up emphasizing the aspects of the neighborhood that are deleterious and not pro-social. So we wanted to get at some of that. So that's a really great role for an EMA. But here's one of the challenges. This is example one for the EMA challenges. So we did some focus groups after our initial data collection. And so we had one respondent say to us, one of the funniest things is that I was at church when it pinged, but I had accidentally left it at home. So I got home and it had rung and I thought, oh, I wasn't at home, I was at church. And I had been home a lot when it rang. So I got back in my car and I drove to church to fill it out. So this is not what we want to have happen. We don't want the instrument itself to alter behavior. So this became an important part. So this is why doing a focus group after our initial data collection was really helpful. We, you know, decided we really had to say to our respondents, it's so important to characterize where you are when that is pinged and to reflect on that if you can't answer, if you're driving a car or whatever else. So, but we thought, yeah, we don't want our pings to do this. I wanted to show you too. So this is kind of getting, yeah, please.
Since you invited her, I am going to ask a question.
Yeah, please.
Because we ran into this dilemma that we wanted to call them every morning and make sure the technology was working, that it was reset, et cetera, because these are people who aren't familiar with it. And we did do that. But our dilemma was we've now introduced social contact. What if they spend all their time alone and this is the only social contact, so it's making a difference? How do you deal with, because you just said you don't want to change behavior, but how do you deal with some of that in your work?
So wait, so say, and when you say deal with it, yeah, say
so how do you deal with both the decision-making of, okay, we're gonna, how did you deal with making decisions about what might alter behavior versus the need for data?
Yeah, I mean, I think this is where the art of it comes in. It's just really hard. We always wanted to, I'll just start with safety concerns, make sure people felt safe when they were answering these. So they're not driving, they're not standing outside in a place they might feel vulnerable. We always wanted to say, like, your safety first before you share your data with us. We understand that people are sometimes in an intimate situation or they are in, a group of people. It's awkward to do that. We do have, we altered this from like 20 to 30 minute window, and you had a lag time too, right? Where people could answer within a particular window, the EMA.
Yeah, you have to.
You have to have that lag. It ended up, in some instances, we just had missing data because, this is a pretty intrusive data collection enterprise, really. But again, I would argue that it's so valuable for really understanding context, particularly of vulnerable populations. The extent to which people feel isolated. I have one slide on loneliness, and we just submitted a paper on this, but trying to understand kind of loneliness is more trait, not state, and understanding, you know, the kind of notion of momentary loneliness and where people felt most lonely, and to be able to geocode that so we actually know these experiences. So I think that's a really important contribution to science, recognizing that, yeah, we're drawing out something that, you know, could make people feel uncomfortable revealing. I mean, you know, in some sense, one of the things that we felt I just shared that quote with you. You know, we felt like, you know, there's some stigma to saying you're alone and to saying you're alone over time. And so getting people to feel comfortable, again, for the purposes of the science, sharing that. That was a bit of a long, winding answer. So I don't know that I completely got at your full question.
No, I think that was really informative, and I really appreciate it, just to hear your thoughts on all that. That was great.
Yeah. We also, you know, thanks be to God, we have great interviewers and people that our respondents can call with questions. And that helped a lot in terms of people's level of comfort with, I think, this constant interruption. I do think in some ways, though, you know, for people who are new to smartphones, we mailed the phones to them. We also mailed the phones during COVID, because as I mentioned earlier, and based on your data, not all of our respondents had smartphones. I'll say too that, you know, so they learned how to use them. I'm working with Bill Copeland and Joe Hotz on a study in the Great Smoky Mountains, and we're using these methods. And it's a little bit younger age sample. They're about the age of health, and we're pushing out an app for them. So just to kind of give you a sense of how age is, you know, being employed. This is just kind of a quick visual to show you, you know, again, kind of emphasizing, did we need to do this 5 times a day? But these are all the places. So this kind of gives you a scatter. This is all our EMAs combined. And this is kind of a fun image of where people are from the neighborhoods they originated from. So some are denser, right? Some are more widespread. It's interesting to see, even sort of, if you will, a neighborhood level effect on that expansiveness. And again, too, but one of the things we notice here, this is Irving Park. This is primarily, just to share it with you, an upper income white neighborhood. And what we see here is that people seem to be moving north. They move through other white neighborhoods, or they go to Wisconsin, but they're not going south, and they're not going to Indiana. Now a comparison, just I think I have the time to do this. If you look at some of the South Side neighborhoods, right? There's no movement. This is primarily an African-American neighborhood. You're not seeing a lot of movement north, right? But you're seeing that movement south and a little bit west. So just to kind of motivate what one could do substantively with these data. So just to, yeah, but again, yeah, so, and this is my example from another example of, you know, from a scientific standpoint. We use the EMA to explore loneliness. As I mentioned, you know, what is this notion of momentary loneliness? So we're kind of trying to push this idea. This is work also with Louise Hockley, who's done a lot of work on loneliness and social isolation in older adults. And so we looked at intensity. We looked at differences by gender and by race, ethnic group, and whether group variation in loneliness is explained by this differential exposure or responses to physical and social context. What we find here, and I'll show you one slide in a moment, is that men reported more loneliness than women. So that was not in keeping with the literature more broadly on loneliness, and that our African Americans in the sample felt more lonely than whites when they were out of the house and alone, and out of the house and not alone, relative to when they are home and alone. And so we thought this was really interesting. And this is a graphical representation. And this is the average marginal effects of that social and physical context on momentary reports of loneliness. And so we think that maybe some of this idea of feeling alone has to do with a sense of agency or locus of control in outside space. And that's an insight that really came from some of our COVID work. And I'll show you that too. So these are the adjusted predictions of being with others, other than those you were with. So remember, I showed you those 2 screens. So you can say, I'm like with a group, I'm with 3 other people, but could be a lot of other people around you don't know, or very few other people around you don't know, but that you're sort of, you have your own set of friends, but you're embedded in this social space. So this is pre and during COVID and those interactions by race, ethnicity. So one of the things, so again, because we were having problems with those GPS data, we turned to our EMA data to get a pre and during COVID kind of comparison that we really wanted. What we noted in this finding, this is something I presented at PAA last week, so I thought it might be fun to include here, is that it looks like the whites in our sample are in some sense being more responsive to, let's say, stay-at-home orders or other things that say that they should socially isolate. So this is the likelihood of being with others. But one of the things we found in our results, so it looks like for our Black and Latino respondents, they're actually potentially with, this isn't statistically significant, but they're with either kind of the same number or that they're, right, just even a bit of an uptick. But we surmise that given the types of places on average where our white and African-American Latino respondents live in the city, Blacks and Latinos more likely to live in multi-unit dwellings, more likely to live at least in some areas that are denser, that they just may have not as much agency in their ability to control that outside environment. And that our whites in our sample might have, let's say, a backyard or live in a neighborhood that has more, let's say, of a suburban feel, where they can more readily control their outside space. And so if you were able to work through example 5, that was the data collection, link that we threw in the chat, so that you could work through our 12 to 15 minute EMA, this is what we ask at the end. We ask about control over where you spent your time today. And we also ask about control over who you spent your time with today. So note here, and again, these are just descriptive data, but I think they're instructive. We look for our Latino, Black, and white older adults, and you'll see, look at how durable that response is for the whites in our sample. So during COVID and pre-COVID, if you just look at those who said they had no control, it's about the same. But even looking across from no to complete control, whites look about the same, right? That the extent to which they feel agency in their day didn't really change that much in the COVID context, but it did for the Latinos and African Americans, both for where you spent your day and control over who you spent your time with. So I don't know, again, these data are truly hot off the press, as we say. So just descriptive, we're kind of thinking through, but it said to us, wow, it was so important we asked those end of the day questions to summarize your sense of how your day unfolded, the arc of the day, because I think it does tell us something about the role of agency and the ability to, again, be responsive to something like directives that come from the CDC. So I know I only have 5 more minutes, and I'm just going to say a few things quickly. I just want to tell you where we think some of this work is going. We did something within our baseline measure called a CAT-MH, which actually sort of uses the same kind of responsiveness measures they use to I'm trying to think of, right, we're not really using standardized testing as much, at least this year anymore, but that it will learn. And so one of the things that my colleagues in the Department of Public Health Sciences developed, Robert Gibbons led this effort, was sort of a shorter measure of thinking about mental health and its indicators. So we want to draw that in to look at depression and anxiety from both a momentary perspective, and then what he developed with this kind of ability to get at a much smaller range of questions that can tap something like depressive symptomatology. We want to introduce this in new contexts. Hong Kong is one place where I've been doing some work lately. And then, this came up in our discussion from PAA, examining virtual places, how they might matter in the way that I'm trying to characterize space. And we haven't done as much work on virtual places. We do know whether people interact with the internet and but we didn't tap that as much as we probably could have. So that's maybe another, I could emphasize that as maybe a 6th challenge in all we're discussing today. We want to try to use some of the paradata from the phones, how quickly people answer that EMA, and see if that tells us anything about mild cognitive impairment. That's a grant we're writing right now. And just to give a shout out, I mentioned the work with Joe Hotz and Bill Copeland. We're collecting data now in the Great Smoky Mountains. So we want to look at questions like, can we apply some of this urban social theory to a rural context? And then we're going to actually elongate our use of the EMA. And so this is something I really did want to flag, that we're going to use it for some questions over a 6-month interval. So every 6 months we'll ping you and say, are you at work right now? If you are, what are you doing? In part, that's to just get a better sense of the labor market and some of the gig economy work that's happening in rural settings.
Kate, I love this, but I have, well, I'll let you go ahead with your thing.
Actually, I'm ready to come to a close. I just want to make sure I shared my email address, the title of these 2 studies that are in the works right now. And I hope people will contact me if they're going to do work of this kind so that I can save you some time and some of the challenges and hopefully, important shifts we made so that the data collection can move forward. But Karen, go ahead.
Yeah, this is phenomenal. I can't even tell you how much I'm getting out of this. My one question, that one where you're pinging them every 6 months, is it on their devices? Are they holding on to your device? Like, how does that work?
So it's on their own devices, okay, because and that's easier to do, right? So they're not holding a second phone. That's one of the things that has been a little harder in so some of our respondents did have their own phones.
Yeah.
And so that was hard to ask them to carry 2. It's much nicer to do it with an app function, and then we can just program this app on the fly.
Yeah. Okay. Yeah.
And I'll just add too that one of the things that's great about the Great Smoky Mountain study, it started when these respondents were adolescents. So there are 11 waves already. They are pretty adhered to this study. It also has really nice representation, the Native American population in that foothill area. And so we have some, opportunities for some important comparisons there, but to have longitudinal data of that kind and respondents who are already, they've already bought in. So to kind of introduce this innovation, we hope, into something that they're already committed to makes it easier.
Yeah, no, this is phenomenal. Your work is just phenomenal. I've been doing all the chatting here with Kate. Does anybody else have questions?
I've appreciated your questions. It's always, I know we all have this of presenting on Zoom just is harder, right? And wouldn't it be fun if we were all in Austin right now? And we could all go to dinner and talk about it. So I know it's sometimes, harder, but I've appreciated your questions, Karen, because it's nice to have, it's easier to present when you're having more of a conversation, I think.
No, this was absolutely phenomenal. And I will still have questions, and I hope other people will email you with questions. We are going to take a break right now until 1 o'clock when we'll be coming back and hearing from Liz Munoz. And it's kind of really great, Kate, because she's going to be showing us how to assess cognition as people go about. So in terms of your mild cognitive impairment, there may be other ways, to look at it. So it's a great connection. So everybody, thank you for this morning. It was great to have you here. I got so much out of this. And so we'll see you at 1 o'clock. Welcome back, everyone. We're really glad you're here. And I'm very pleased to introduce my colleague, Liz Munoz, who will be talking to us about ambulatory assessment of cognition and the work she's done in that area.
Thank you, Karen. I'll start sharing my screen. And so the way that I formatted this presentation is pretty much, you're welcome to share your experience as well. I'm just basically sharing my experience doing ambulatory assessments of cognition. So at any point, if you have any comments or similar experiences, feel free to chime in. So I'm very happy to be presenting today. And you can see my presentation, right, Karen or Stacy? Okay, great. On ambulatory assessments of cognition throughout the day. So I thought that I should start by saying where I'm coming from for this type of assessment. So I am not a programmer, I'm not an app developer, or even a neuropsychologist. So I am a developmental scientist, and the way that I come into this area of study is through my interests in daily experiences and cognitive health. And so I have worked in studies incorporating ambulatory assessments of cognition from the planning and piloting phase through the data analysis and reporting phase. And so one thing that I can truly say from these experiences is that this is truly a team science effort. So I do want to start off my presentation by acknowledging all of the wonderful folks that I've been lucky enough to work with throughout my time. So here are all of them, as well as funding, of course. And so what I'm presenting on today is basically based on what I have learned from mentors and colleagues listed here on this slide. And more specifically, I do want to give credit where credit is due and acknowledge Marty Slowinski and his team at Penn State and Nelson Roque, who are key players in the development of these types of assessments. So they do the hard work of developing these assessments, and I get to incorporate them in data collection projects. And so a few years back, we worked on a project that led to the development of ambulatory cognitive tasks that proved to be reliable and valid assessments of cognitive domains, that we set out to measure. So these were specifically working memory and processing speed. And in this project, we showed that there was construct validity and reliability throughout the study period of these assessments. So we showed that the cognitive tasks that we developed tapped into working memory and processing speed specifically, and that we showed reliability across the study period, between person reliability in these assessments. And so this study kind of served as the nexus for later and larger projects, one of which is meant to develop and validate more cognitive tasks with the goal of this being easily accessible to investigators in the very near future. So Marty Slowinski, the lead on this project, is developing the cognitive tasks that will be available through the NIH toolbox. So we'll be able to download them freely. And the reason why I wasn't able to provide an app right now is because we're still working with prototypes and finalizing the apps before they get released.
Later on, Liz, maybe during the break, could you put a link or just put the DOI for that paper in the chat? Because Matthias was saying it's really groundbreaking, and I think folks would love to just be able to access it.
Definitely, yeah. I'll definitely share the link, and I'll share the link to the project if you're interested in learning more about it. And so what I thought I would do for this presentation is that I will address the what, the how, and the when of ambulatory cognitive assessments, specifically in adults. So start off with the what of ambulatory cognitive assessments. So really the focus is on smartphone devices and smartphone applications. So these assessments can be done on iPads, for example, but like Karen mentioned at the beginning of the workshop, because we're interested in obtaining these assessments throughout the day, smartphones are the best option since participants can carry the devices with them throughout the day during their everyday life, and we can measure their cognitive function as they go about in their daily lives. And like others have mentioned, this type of assessments enhance ecological validity because we're measuring a person's cognitive function within their natural environment as they go about in their everyday lives. And these types of assessments can also help improve reliability of measuring between person, or what we call individual differences in cognitive function, right? So if we think about the way that we traditionally measure cognitive function in the lab, typically we rely on what we call single shot assessments of cognition. So we bring them into a testing room and we assess their cognition. And we know that these assessments could be influenced by random or systematic within person variability. So the person might not have had a good night's sleep the night before, or maybe they experienced the stressor before coming into the office to get the assessment. And so those types of influences are difficult or even impossible to control when we do the single shot assessments of cognition. So being able to aggregate across repeated ambulatory assessments of cognition allows us to essentially cancel out these effects and can improve our measurement precision and reliability by being able to estimate average level functioning for each individual. And lastly, what I'm essentially most interested in is that we can link daily behaviors and contexts and states and to these measures of ambulatory cognitive assessments. This works. Okay, so a typical survey setup for these kinds of assessments that I work with first gathers some information about the context that individuals are in, right? So we may be interested in associations with contextual influences, but also getting a sense of where the person is or what they're experiencing can help us account for that variance, right? That can influence or that can introduce error into our measurements and thus help us get a more reliable estimate of an individual's cognitive status. So we ask them questions like this: where are you, for example, and that can give us a sense of where they are. We ask them questions about their stress, things, whatever it is that we're interested in. And then also questions about things that may influence their cognitive performance, right? So are they sitting, standing, reclining? So things that can come into play when we're thinking about their cognitive function. And then once we get some idea of their context, then we prepare the participant for the cognitive task. And then we follow this up with instructions and then the tasks themselves. So I thought that since this is a more dynamic sort of presentation, I can show you what the apps look like. So I'll connect my phone and show you exactly what this sort of surveys look like. So I have a phone here that I'm testing, so I'll plug it in and share the phone basically. Let me just get out of the PowerPoint. I forgot my mouse, so I'm doing the laptop trackpad. Okay. So I'm hoping that you can see this, the phone screen. Hopefully you can, but if you can't, let me know. So this is essentially what the app looks like when the participant opens the app. And we have, surveys in the morning and at night. And so I'm not going to go over like in detail over the survey questions since that was covered before. So I'll try to like breeze by the survey questions. So this is a project that we're still testing and seeing how many questions we can include before we have the cognitive tasks, right? Because we want to keep the survey short, less than 5 minutes. And so this is a lot of questions.
I'm going to break in and ask you, that little sliding scale thing, we had some problems with that, getting people able to use that who aren't familiar with devices like this. Could you, could you?
Yeah, so we decided to include a slider and without the actual values because we don't want participants to remember exactly what they tapped the previous survey. And, sometimes they kind of want to be consistent in their responses. So not having like showing them the numbers. So this ranges from not at all 0 to 100. So when we get the data, it's from 0 to 100. And we actually found that this was pretty accessible for participants if we train them. So we have, I'm going to talk about that in a little bit, that we have to have a training session before they take the phones with them. And we tell them exactly what we mean when we give them the slider and then try it out themselves. And if they have any problems, then they can let us know. But we haven't run into any issues, maybe because they're middle-aged participants and not older participants. Is that what you think? I think you're muted.
I was also wondering in terms of like arthritis and things, because that's a really precise thing you have to do. And so if I, you know what I mean? Like, I don't know if my hands aren't working well, how precise I can be.
Yeah, and they don't have to basically drag the thing. They can just tap at the end and then the dial changes. But I know that there are other options where the line is thicker, where they can tap a bigger area. But yeah, I do understand that that could be an issue for sure. So I'll just breeze through the survey questions. These are just questions that we're asking. We're also asking them where they are, who they're with, and of course their posture. And we're also interested in like ruminative thoughts of worry. So we include these questions here, activities that they've done since the last survey, and positive experiences, stress. So just a lot of things. So I'm not gonna go over that too much in detail since we covered this topic already. This is a study specifically focused in Latinx adults. So we're asking them also about their experiences with discrimination. And one of the parts of this project is that we are aiming to also validate this tasks in Spanish. Okay, so this is where they complete the task, the survey questions. There's a lot of questions, so I'm aware that we have to trim those. And then the cognitive tasks begin. And we call them brain games to kind of make it fun for them. And we give them some instructions. So you will be presented with instructions for the dot memory task. And so they'll see 3 dots on the grid, try to remember their location, and then we give them a distraction where they're supposed to tap all the Fs on the screen, and then they're supposed to recall the location of the dots. And so this is a measure of working memory. And so then the task begins, and so we ask them remember the dot locations, and then they're supposed to tap the Fs. And it's really more, we give, I believe it's 15 seconds in between. So really they don't have to finish all of the Fs. It's more of a distractor task to really tap into the idea of working memory. And so we have this. I completely did not pay attention, so I'm just guessing. We have 5 of these trials.
Liz, I'm sorry, can I ask you another question just as we're going? By the way, folks, Liz had also texted me that go ahead and jump in if you have questions.
Jump in, because I don't have much
Okay,
data.
so my question here is I don't have the best vision, so I can't really see the difference. The slowness for me is the vision and not the response. How are you dealing with that?
So there's no timing in with, you meaning the Fs or you mean the dots? Because
I mean the vision, visual, like what if I'm slower because I can't see it as opposed to the,
yeah. So I know that the colors that we chose were have been sort of validated to be or be accessible to people with you know, the color visual impairments related to color. In terms of vision, I'm not really sure if we've discussed this. I know that there's a reason why we also have iPads for some participants. But yeah, that could be a problem. Definitely.
I have a question too about the order. Have you guys thought about randomizing the order of the cognitive test with the other measures? Or?
Survey questions, you mean? Because we asked the survey questions before. Yeah, so there's an ongoing study that is basically doing that. It's mixing up the survey questions and the cognitive tasks to see if that has an influence, right? Because yeah, typically we do include the cognitive tasks at the end, but that is just because we thought that's just the way we've been doing it. But it could be that, you know, the questions that we asked before can distract the person, right? So we ask them about a stressor, and so now they're distracted thinking about the stressor and they're not paying attention to the cognitive task or something.
Or they're just irritated because they've been filling out questions. And just in general, I think at the end they're just tired.
Exactly.
Exactly. Exactly.
Liz, may I jump in too? Since
of course.
Do you pay attention to the timing, how long it takes them to do the exercise?
Yes.
Not just that it's right, but sorry, go ahead.
Yes, of course. Yeah, no, definitely. Yeah. So we get that data from the survey when they were presented, the screen was presented, and how long it took them to tap the first dot, basically, right? Or yeah, exactly. Yeah.
Okay. Cool.
Yeah,
thanks.
Definitely. Yeah. So we also have this other task that's another working memory task of a binding task that we ask them to remember the colors and then and the shape and the colors. So the location doesn't matter, but remember the shape and the colors. So you'll see the different figures here, and then they're supposed to, and then another set of figures will show up, and then they're supposed to tell us if they're the same shape and color or not. So and then they say same or different. I'm not paying attention, so okay, I'm not sure.
I'm sorry, Liz, I missed it. How much time do they have? Is this the speed at which it comes?
Yes, it is.
Wow.
Yeah. So we so we basically it's a difficult task basically. So yeah, so they it's not the easiest task. And then this last one is the processing speed task. They're just supposed to tell us if one of the figures at the bottom matches one at the top. Right, and I'm just guessing here.
And during your training, do you train them how to do the task?
Yes. Yes, so I'll go over that. We have a session that goes from 30 minutes to an hour, where we basically go through every single question on the survey and every single task, and we ask them, then we tell them specifically what we're expecting. And then after the task is complete, we also ask them if anything interrupted them during the brain games, so that we can control for that. And then that's it. So yes, I'll go over that in a second. Let me share my slides again. Huh. Okay. Oops. So yeah, so that's just an example of what this task look like. And like Kira showed this data, there's a lot of variability in this data across sessions and across days, right? So there's no stability in their performance. And so this is when we can look at how different factors relate to this, their performance, right? So this is a dot memory task. And so in this task, we calculate a Euclidean distance from the accurate response to where the participant responded. So the closer they are to the correct response, the lower scores they get. And so this is just an example of another spaghetti plot that we can get, right? Okay, so most of my time will be spent talking about the how of this sort of assessment. And so just again, what Karen said, type of device is important. So as I mentioned, smartphones are typically preferred for daily assessments, but can also be incorporated on iPads or potentially any other handheld devices. And then another thing to consider is if you want to provide the phones yourselves or allow participants to use their own phones. So what we call the BYOD approach, bring your own device. So things to consider is that, like Kate said, some participants may not have smartphones, right? So we may have to provide the smartphones to them. So one of the studies that I worked with was also pretty low SDS sample. So we provided the smartphones to them. Another thing to consider is whether the application you're using is compatible with the participant's phone. So these apps right now work very well with Android, but not with the iPhones. So if the participant doesn't have an Android, then we definitely do have to provide a phone to them. Or you can have a hybrid approach. So one of the studies that I'm working on, we have a hybrid approach where they can bring their own device, or we can provide the phone to them so they can choose what they want. One thing that has been an issue with bring your own devices is that some of the data collected through the application is the operating system's assigned device ID. So every operating system, all of our phones have an ID. So those data can be sent to us, and that can potentially, provide personally identifiable information. And so one thing that we've done is that we've kind of, not me, my collaborators have developed a way to kind of record that variable before it even gets uploaded to the server, so that we don't see that ID and it's not, providing any identifiable information. And like Karen said, the operating system matters. So right now we can work with Androids, but we are in the testing phase of iOS, and we think that we will be able to have that for the at the end of the summer. And then another thing to consider too is that the devices that participants use differ in terms of their interfaces, right? So screen size differs, response time may be different. So one study recently, like that was published this month in Behavior Research Methods, they showed that devices that differ in their interface perform differently, and the device type that participants brought into this for their study also was correlated with SES. And so more educated individuals tended to use iPhones, for example, right? So that's something that can introduce more variability into our results if we are providing the device, or are allowing participants to bring their own devices. And then another thing too is data storage. And so a topic that has been brought up, right? But what I'm referring to here is more on how the data are stored while the participants are completing the study, right? So we can have data plans on the phones and allow for the data to get uploaded onto a server essentially in real time, right? So we can see their data every time they complete a survey. It gets uploaded to a server that is costly to maintain, but it's really great because we can see their data in real time. And also this kind of approach allows us to have the data even if the participant doesn't return the phone, right? So we've had instances where the participant doesn't return the phone to us, so we at least still have their data. We haven't lost their data, right? If we choose to not have a data plan, not have connectivity to Wi-Fi, for example, which is probably not recommended, then the data gets stored in a device in the file system that the application has. And so we get, once the participant returns the phone, we connect the phone to our computer and we upload the data, right, to our computer, and we have the data. And that's great, but that's provided that the participant returns the phone, right?
Liz, I'm just going to make a couple of comments on that. We provided, as I said, and what we did is we got just last generation, so close enough that they were still update on the system, but not good enough that anyone wanted to steal them. So we got relatively cheap Androids, and you can get them a lot less expensively and buy them in bulk and whatever. So yeah, and we had an interviewer go to retrieve them so that we got because we also had those ActiCals. We wanted to get them back. So, but anyways, just
that's a good point.
To the wise, because even if they don't keep them, you don't know what kid has come into the house and saw that grandma had whatever and walked off with it.
You're right. Yeah.
Yeah, the other thing, we have people sign that they have to return the devices to get their payment to participate. So there's an incentive.
That's a good point. Yes. And I'm sure you also lock the phone, right? So that they can't access anything else except the app, the survey app.
Yeah.
We had a participant who was able to break into the phone and got through and was using the Wi-Fi on the phone, downloaded Facebook. So yeah, pretty savvy people. But yeah, those are the outliers basically.
And for your app, who is developing your app? Like, are you using?
Yeah, we essentially hire an app developer who works on Android apps. He makes games on Android, and he is like basically staffed on the project to create these apps. Yeah. So another thing that I also wanted to bring up that came up is that we train participants before in person. So we, especially because we wanted to get the in-lab cognitive assessments to compare them with the phone, we would have the participant come into a lab session. And during that session, we also have a training session that is around 30 to 60 minutes, depending on how long it takes for, we just let the participants ask as many questions as they want. And we walk through the specifics of the phone as well as the survey questions. So we go through every survey question and we tell them essentially what we mean when we're asking them something, and so that they're comfortable with the questions. And then we go through a survey with them before they go home and start the survey the next day. So things to prepare ahead of time is training presentations. So we prepare a PowerPoint presentation where we essentially take screenshots of every question of the survey. And then we also specifics about how to charge the phone, when to charge it, things like that. And we type out a script for the project, whoever is doing the training session, right? So a research assistant or a project manager who's gonna run the training session, they just essentially read through the script that we write out for them so that there's consistency for all participants. And then we also have a take-home handout that's just basically the basics of this is how you charge your phone. This is when some participants start after their training session. So we have a section where we tell them you start this date, your last date is this. And then we also have an emergency contact information. If they have any problems, then they can call this number. We also include that emergency contact on a sticker on the back of the phone so that they can call if they have any questions. And then another thing is that we do, I'm sure you all do too, we ask for feedback from participants about their experiences with the survey. So this is a sample set of questions that we ask. And one study, we had 300 or so participants that completed the study. They completed 5 EMAs for 14 days. So we beat them 5 times a day for 14 days. And we found that the majority of the participants found the surveys to get easier with practice, and less than half said that the protocol was annoying, which we thought was fine. Very few found the questions repetitive or boring, despite this being a 5 times a day for 14 days study. And very few said that they intended to drop out. So this was also a study where we followed them every 6 months for 3 what we call bursts of assessments. So they returned after a while to complete the same protocol. And then we also at the end of the survey asked them if they had a typical 2 weeks or not. So was this a typical time in your life, or did you experience a major change or something, that we could account for that could have influenced their performance on the cognitive tasks and also on the surveys themselves, right? And then another thing that we started doing is that we gave feedback to participants. So they thought that the brain games were really cool, but they wanted to know how they were doing. And we know that the problems that could come from providing feedback to participants based on their survey performance, right? Specifically when it comes to cognitive tasks, the way that to interpret this is not really straightforward. So we didn't want to give them something that will kind of make them feel like, oh, I'm not doing well, but they were very intrigued with these tasks. And so we did end up providing feedback to them. So this study involves actually siblings. So it's either adopted or twin siblings. So we also wanted to make sure that the participants could not compare their performance to their siblings, right? And so what we did is that we created plots essentially of their performance, but that was relative to their first assessment, so that they could not, there was no way for them to compare their performance to their siblings. This is just person-specific feedback. And so here in this study, we had 4 tasks. We also had a shopping list in addition to the dot memory and symbol search. It was more of a measure of episodic memory. And so this is just an example of what we did. So we tell them specifically what this means. So each point on the graph represents your accuracy in remembering the location of the dots. These are relative to your own performance on the first day. And then we tell them symbols closer to the 0 point, and here we have the 0 point, mean that your memory was more accurate, right? And then we tell them you were spot on 4 of the trials and stuff like that. So participants in this study specifically seemed to enjoy it. So in this survey, we also asked them if compensation was a reason why they participated in this study, and they said no, that they enjoyed the feedback more. But one thing that I do want to stress is that this study is a longitudinal study. We've had, these participants have been coming back every year since they were babies. So they have a lot of fidelity to the study, and they're committed to the study, right? So they enjoyed this because it was new, basically. Okay, so things to consider when filling out an IRB application, in addition to all of the other points, right, that we have to think about when we're applying for IRB approval. First, we need to describe what the surveys are and how they work, and then also tell the IRB what type of data we're collecting, right? So of course, we're collecting performance data. So trial by trial information, information about the stimuli that's shown during each task, display times, response times, response options, and then what they selected, right? So that we can calculate, you know, their accuracy. But then we also have metadata, right? So the date and time that the notification was sent to them, and the date and time that the participants, when the participants started the survey. So similar to what Kira showed, when they were beeped and then when they started the survey. Also, if they, what screens they viewed during the study, right? So maybe they didn't complete the whole study, the whole survey. So up to where did they kind of like logged off or closed off the app? And then we also have data on the device make and model. And like I said, we have an OS assigned device ID. And so that could be identifiable if we have a BYOD approach. So that's something to take into consideration. And then also hardware data. So performance of the hardware during the assessment, and then information provided by the phone sensors like brightness of the screen, volume, and GPS, right? So during the testing of the surveys, it is critical for us to check which sensors are being accessed by the apps, because this could generate personally identifiable information. And so if we notice that, you know, GPS is being accessed, then we have to make sure that that's turned off, right? And then we explain how data are stored. So if we're using the approach where the data are being stored in devices and then they bring it back, usually the default behavior of applications is to store all of the data inside a hidden protected application file folder. So kind of like hidden files that we have in our Windows operating systems. And then we also, you know, state that the data are encrypted. They're stored encrypted on the device's internal hard drive until it's successfully uploaded to the server, right? So if somebody else were to access the files, it's just gibberish and they can't make out what's in those files. And then if we do end up using a server, then we have to state how the data are being retrieved, right? So are we using a specific interface to retrieve the data? Who is retrieving the data, right? So usually we have to say it's researchers who have been approved to have access to this data and things like that. And then how long the data are going to be retained, and specifically state if personally identifiable information will be collected, right? and how we will prevent this data from being collected. So we have to specifically state that GPS is going to be turned off, for example. Okay, so last, I want to just talk about when we do this assessment. So when do we introduce this assessment? The goal is to measure cognition throughout the day. So we definitely want to have enough assessments per day, but what is too much, right? So the question is, how many times per day do we send notifications? And from my experience, that it really depends on participants. So, and based on piloting the protocol. So, like I said, we've successfully implemented protocols that beeps the participants 5 times a day for 14 days. We tried the same protocol in another group of participants, and they were not happy with how many times they were getting beeped. They were, these are midlife adults, and a lot of them were concerned that they were getting beeped during their work, and that was not feasible for them. And so we ended up changing the protocol to 3 times a day. And based on the first paper that I showed at the beginning, we found that we were able to obtain good reliability after 3 days of assessments in that protocol. So that was 3 days of 5 times. So after 15 assessments, our reliability was pretty good. So as long as we're able to get about 15 assessments of cognition, if that's what we're interested in, then we felt comfortable. So we ended up cutting it to 3 times a day. And then I'll show you exactly what we did to kind of make it a random setup, but not really random. So we wanted to make sure we beat them maybe before they went into work, maybe during their lunchtime, and then maybe after work, right? So I'll show you how we ended up doing that, which goes in line with this other point of whether we want the assessments to be random or fixed, right? So if we want the assessments to be random, this really, or being able to have random assessments really increases the representation of a participant's daily experiences, right? So we're able to capture more of their daily experiences as opposed to fixed times, right? So these are more predictable. So participants are going to know when they're going to get that notification. And it also provides for fixed time blocks, which actually would be better for data analyses, right? But not for what we're interested in, right? So it really depends on the research questions. So do we want to know exactly how they perform in the morning and midday at night? Or do we really just want to get a random sampling of their these experiences so that we can get a sense of what a person's typical life is like, right? So those are questions that we need to think about. We were interested in implementing a random assessment sort of setup, but we also were concerned about the participants not being happy with being beeped during their work. And so we developed what we call pseudo-random schedules that looked like this. So we developed schedules that were specific to when the participants tended to wake up in the morning. So we asked them, when do you usually wake up in the morning? So we had schedules for individuals who wake up at between 5 and 6 a.m., 6 and 7 a.m., 7 and 8, and etc. So we created these schedules, and we set it up to beep them between 4 to 5 hours, between every 4 or 5 hours, so we can get a kind of a distribution across the day, but also set it up in a way that they're not predicting when they're going to get their beep, right? So they're not like sitting there on their desk thinking, I'm going to get beeped in the next minute, so I need to be ready for my survey, right? So that's kind of what we did. So we just essentially set up all these profiles, and then they get beeped that way. So yes, I think that's all I had to say. So yeah, basically we don't want them to know when they're going to get beeped, but we also don't want them to beep at times that are inconvenient to them. So I hope I know I didn't cover everything that it goes behind the scenes in this sort of type of method. but I wanted to give you a sense of things that could be taken into account when you're working on these assessments. So thank you. And I think I have like 2 minutes. So if there are any questions, I'm happy to take those.
So yeah, we'll open up for questions. Does anybody want to join in? Soo-Young, you want to go ahead?
So Liz, thank you for this amazing presentation. It's just so exciting to see what you're doing. My question for you is, with the assessments that are done online with the internet connection, are you assessing both the reaction time and accuracy of your cognitive assessments? And if the person is using an internet speed that's slow or fast, does it matter if you analyze the reaction time? I'm just curious about devices that are offline that you give them versus done online, and how comparable that data would be if you're assessing reaction time, because most of the time reaction time is assessed in milliseconds.
Yes. So we don't use Wi-Fi first. I guess that's my first point. We either use a data plan or we turn everything off, and the app is collecting this data, right? The response time data. And so the app is programmed to collect the millisecond-based data. Is that what you mean? So yeah. we don't rely on connectivity for the collection of the data, if that makes sense. So it's all through the app.
Okay, so the app is also installed on the person's own device. So then you have control over the reaction time because it's collected through the app.
Yes, exactly.
Okay, that's brilliant. That's brilliant. Yeah. Thank you.
Yeah, so we don't do we don't connect them to a browser basically, right? And then they complete the tasks there, because that introduces more error. Everything is coded and programmed within the app. And so it can work on or offline.
Gotcha. Thank you so much.
Liz, I've got to ask one last question, and that was, we've never asked about posture. What do you need to know posture? I think that was so intriguing.
Yeah, so this was based on a paper from, I forget, it was like 10 years ago that this was published, where they showed that there could be influences based on whether if the participant, and this was in the young adults, whether they were sitting or standing or lying down, which kind of makes sense in terms of like how they're holding the phone, and if that could kind of influence the ability to respond fast enough, potentially. So that's just another question that we put in based on that paper that we read.
That is absolutely terrific. Thank you. This was such a great, stimulating talk, and fits so well with things we were talking about this morning. We're going to take again a 15-minute break. We'll be back at 2 p.m. Central Time. And now I'm going to turn it over to Matthias for really one of the most interesting devices, well, not devices, but apps that we've worked with. And so I'll let you share that. Go ahead, and thanks again.
Thank you, Karen. Thanks for inviting me. This has been such a great workshop. So I'm going to talk about the ear method, and the ear method really is at the heart an ambient sound sampling method. And in some way, I think because we're talking about ambulatory assessment, one needs to wrap one's head around what is it? I mean, is it experience sampling? Well, not really. Is it like an objective test, like cognition? Well, not really. And so you need to think about, well, it took me a while, it took me a few years initially kind of to construe of it as in methodological terms. And the closest analog I could come up with was that essentially what the self-report, I guess in the lab or over Qualtrics, is to experience sampling. No, sorry, what the self-report is to experience sampling. Behavioral observation in the lab is to the ear. So what we have, what the goal of the ear is to say, well, doing EMA is it provides you the in vivo and in situ perceptions of the person, internal perceptions in terms of feelings and mood, and external perceptions of the social world, and it does that without cognitive biases. But we know that there's certain things that escape kind of or at least are not optimally assessed in self-report, and that's when we use observational methods in the lab. And in the same way, I think the ear is an acoustic observation method in the real world. So it's very complementary. And I think, just as a side note, kind of to throw it out there, what I really love that also became so clear in this workshop, and we have we're in the process of editing a handbook of mobile sensing. And there's all these cool sensors out there that you can put on people. And then we're going to have a chapter that's called Viva Experience Sampling, like long live experience sampling, because it's really clear that as we hook people up with sensors, we often can't make sense of those sensors absent the person's subjective experience and what the person thinks and says. So experience sampling will survive. I can guarantee you that as mobile sensing moves forward. And I find it's in the same way also, experience sampling is beautifully complementary with the ear method. So what does the ear method do? And I don't know how familiar people are here. We can go through this pretty quickly. It just, it is an audio recorder, and in the good old days when it all started at UT, it was a micro cassette recorder, and then it was one of the first digital audio recorders, a Sony audio recorder, and then it became at first an iOS app, interestingly, and now it's well, actually Pocket PC app, and then iOS app, and then now an Android app. But the heart of it stayed the same, that we periodically or intermittently sample ambient sounds around people for short periods of time. Usually we go with 30 seconds, and we'll talk about where there's better ways or other ways. And usually we do this about 5 times an hour. If you really hands down want to know why we're set 30 seconds every 12 minutes, I almost need to laugh, because because that way, a full day of sampling fit on a 45 minutes microcassette of the very first one. And I called up the participant, would you please flip the tape, and so on. So, but the 30 seconds has actually proven quite useful. So what you get, what our raw output really is, I mean, in experience sampling, it's a series of numbers from the experience. I mean, here we have an acoustic diary, an acoustic journal of a person's day as it naturally unfolded. So in the morning, you hear dishes and maybe coffee making, and you hear maybe toothbrushing, and you hear going to work, if outside of a pandemic, I guess. And I mean, it's just an acoustic log of a person's day as it unfolds. That's our raw input material. In that, and we're going to listen to a few sound files, it really has almost a flavor of kind of an ethnographic method, except that the ethnographer is not there. The ethnographer is kind of the mic at the participant's lapel or in the device. And so, and it's very rich material. And I often get asked, could you analyze this in different ways? So we've kind of tortured these beautiful ambient sounds and turned them with all cruelty in the numbers into zeros and ones. And a lot is lost in the process, really. I mean, when you listen to them, they're so rich. And I'm sure there are very different ways to analyze this. I mean, qualitative methods, qualitative approach. I've talked to qualitative people. They tend to say 30 seconds doesn't give them enough. So we would need to have longer segments to really get the context, which is ironic because we have to deliberately strip the context off in order to protect the privacy. So we've deliberately kept it short so that you don't get the full context of the interaction. But of course, if you do a real qualitative analysis, you exactly want the context. So yeah, but we have taken a quantitative approach to that. Just to show, and there's lots of privacy considerations. In fact, we're going to talk about that later. Just to show, I mean, the method has now, it's hard to believe, but it's been around for almost 20 years, I think, yeah. And it's been used increasingly by and I'm really happy by many research groups who do this way beyond me. And I'm sometimes involved very peripherally, but sometimes also not at all involved. And that's really great. And so you see, we've done this in undergrad students and faculty members and healthy working adults. And here is like one of the key studies is Karen's study with older adults. We did a small project there as well. Postpartum mothers, Sonia Demijian. Fathers of toddlers, that was a really cute study that we did, tracking kind of how fathers talk to their kids, to the toddlers. In fact, Kelly Venture was the lead on that. Recently divorced adults. So you see like people with depression, borderline, schizophrenia, cancer, arthritis. And in all of those, I think by and large, the method acceptance is, maybe you would say surprisingly good, because maybe you would initially think that why do people allow you to kind of eavesdrop on their lives, which is a pretty sensitive thing. and the acceptance and validity is pretty good in both clinical and non-clinical samples. Why do participants allow us to sneak into? Actually, that I should clarify that we're not sneaking into. Why do they allow us to listen in on their lives? And I think it works because, and it only works if you convey why you're doing this. If you just say, here, wear this device, it's not going to work. They need to understand why. So if I take our study with breast cancer patients and their partners, we told them that we really want to know how breast cancer affected their daily life, or our arthritis patients, how does arthritis show up in your daily life? How does it change your daily life? And I said, and we understand that you want to tell us all those things, but there's many things you don't remember. So for example, how often have you laughed today? How often have you sighed today? How much time have you spent talking? Well, it's not about them not wanting to tell us. It's just no way that the human mind encodes it like that. And so you need to make participants collaborators, and it's actually not that difficult because they understand that. I mean, if you make them understand what protections are there and that they have control over their data, which we do, they are very willing to participate because they understand the benefit of really honing in on those little aspects of daily life. So I don't know how much I should go over that, but what are I mean, when you develop a new method, you say, what does it add over, say, things like experience sampling? And that was initially in the first grant applications, that was a big thing because it's much more labor intensive and much more absorbing and expensive than experience sampling. So why would you do this? And I think we have now enough data to kind of come up with three different or largely different aspects where there is a unique psychometric added value. And the first is that the ear can measure things in a really very concrete act frequency approach. It comes up with very specific concrete behaviors in a metric that we understand. And there are several studies that I could mention, but one is the most dramatic, if you want, so it's probably the one that led to kind of the claim to fame of the method, which was when we looked at gender differences in talkativeness. And we sampled, we sampled like 30 seconds every 12 minutes, so we can do the math. That was about 5%. We count the words that we recorded, and then we extrapolate to 100%, and then we can estimate the gender difference. I mean, what's the difference between how many words women and men use on a daily basis? And maybe that shouldn't be such a shocker, but to the shock of many, there wasn't really a big difference. And I think it's important if I tell you, well, the effect size is 0.10, you would say, all right, that's fine. But if I tell you that both women and men spoke around 16,000 words a day, and the difference was about 500, and the least talkative had 800, and the most talkative had 4,800, then I think you can grasp it, right? Then the numbers become, I mean, that's how our brain thinks. It becomes calibrated to a metric that we can understand relative to these arbitrary metrics like rating scales or many effect sizes, actually. And I think it can do that. In the same way also, like we found that people who are engaged in more social interactions are happier. And the effect sizes, it is what it is. It's like an R of 0.2. That's not too impressive. But if you then look kind of how much we estimated, the difference between the least happy and the most happy person is 4 hours of interactions. So then you can grasp it and like, wow, my gosh, 4 hours of conversations a day, that's a lot, right? And that's a correlation of 0.20. So
Matthias, can I ask a quick question? For us, we find that we have some assessments throughout the day that are either they've turned it off or we think they were napping or something. And how do you, because you're giving totals, how do you handle that some people wore it longer and some people didn't and so on?
Well, and this is when this is where we go into this automatic voice activity detection. So what we do, ours is expressed as the percentage of sound files where a person is talking relative to all valid waking sound files. So we have two categories, and we're going to see those. And one is, does the coder think there is a reason to believe that the file is invalid? Yeah. And mostly that's non-compliance. I mean, we also have like technological problems and things like that. But encoders are actually pretty good at that. We validate against some other indices. that if there's nothing going on, I mean, you're going to hear in the sound files, if there's just dead silence, then probably the person is either sleeping, and that we can see kind of from the time, or it's invalid. And that has been useful for us. And we heard a talk by Kate about loneliness and time alone. And so one of the tricky things to automation actually for us is to separate out silence that is alone time from silence that is sleeping versus just non-compliance. Because so we had a project that was funded by IARPA where we promised to do this all automatic, and that was the big challenge. I mean, to identify talking was challenging enough, but we didn't know what the denominator was. How many valid sound files people contributed. So that's a challenge. I think in your study, the way I understand it is that I think your Adobe Audition approach is you identify the sound files, but I think it gives you also, I forgot there was a deal, but you do have actually a sense of the valid waking sound files. But that's challenging to do that automatically because we don't just want to know how many sound files contain speech. We do want to know how many sound files contain alone time. But alone time is interesting because in alone time, you do hear voice, you do hear noises, you hear keyboards, you hear in the kitchen, you hear, there's always some sort of background noise. So complete absence of noise to us usually kind of is an indicator of non-compliance or sleeping. The other aspect is that sometimes we want to, we know what people think about themselves, but sometimes we need an independent criterion to hold that to a standard. And an example is a study that we did a while back with Nairan Ramirez, and this was around whether Mexicans are more or less sociable than Americans. And you can have participants in two places, Mexico and here, complete a sociability questionnaire, but it's different to kind of see how sociably they really behave in daily life. And in this study, we found that Americans actually, somewhat surprisingly, but not really, if you read about response biases and how impression management works and things like that, that Americans reported being more sociable and talkative. So that's kind of an extrovert, a facet of extroversion, and then one item of the BFI than Mexicans. But with the ear, we captured Mexicans considerably more in sociable behavior, and specifically, so while Americans said they were more talkative, Mexicans talked 9% of the time more. So, and it's important that we don't kind of dismiss one of those sources, because I think both are really important sources. One is kind of how you construe your self-concept, and the other one is how you behave on a daily basis. And so many things feed into the self-concept. So mostly you need a way to assess the two independently. I mean, we have the same thing, I think, with loneliness and time alone, or I think subjective and objective social isolation and integration, that when we measure objective social integration, we typically do it over self-reports of engagement in roles, self-reports of number of friends and things like that, where it's okay, but it's kind of the best we can do at the moment. Ideally, we would have, I think, a source of information that's independent of the self-report. And last but not least, we can do some things, and I hinted at that there's just no way people can remember that. So like laughing, for example, or people's language use, people's word choice. So we found that people's word choice, the words people spontaneously use related to their working memory. We've used spontaneous language use to relate it to inflammatory gene expression. And we just recently published a paper that I really like because it was a real head scratcher. We looked at sighing, and wouldn't most people think that people who sigh more are on some level higher on negative affect than people who sigh less? Let that be anxiety, depression, fatigue, you name it. And we didn't find that. There was really no association. In fact, there was a replication study of a small study that we did where we did find it. And I think we want to correct the record because now we have thrown about 500 people at that. And it wasn't really that sighing rates at the between person level. I should say very importantly, it doesn't predict. So we're like thinking when we do this within person, we're probably more likely to find that as people sigh, they're probably more in a state of negative affect. So how do we do our research? Well, we use an app. There's an app for that. We used to use the iOS app for a while, but then we had to retire it because iOS, I mean, the other presenters have mentioned, particularly Liz, that Android, I think, lends itself better to that. I should point out it's 100% free, and that's a double-edged sword. It's good because it's free, but it's also hard and bad because if you paid a lot of money for it, you would have professional support, and so we have to rely on. I mean, we can update the app when we have funds to do so, and so I'm anticipating hopefully another grant coming in the fall that would allow us to pay the programmers to do so. Nevertheless, I have to say I'm kind of proud how we've maintained it over the years, yeah, I think, but this is like the future of the year. We can talk about what will happen with it. So this is the current app, and we don't have to go into detail. The first screenshot is just the main timing app where you put the user ID. You say when do you want to start, when do you want to end, and when do you want to not record at night. Very just the basic parameters. The second one is the settings screen. The first part of the second settings screen. And there you have a number of settings to go through. Most importantly, how you want to sample, like how much of the time do you want to sample? 10 seconds every 5 minutes, as you see here. That was for different studies, 30 seconds every 12 minutes. It's 50 seconds every 9 minutes. And do you want to give participants a chance to press a privacy button? And I think this app is, I forgot which one you used, Karen, I think that's after your study. And so we have a privacy button that we can press, and that guarantees the person, in this case, 10 minutes of non-recording. And there's other settings. You can actually now, you can do random sampling, which Liz also said. There's pros and cons to that. We can do GPS sampling. We've never done that, but you could GPS tag an ear sound file if you so wanted, and it would compound, of course, all the privacy complications around it. We have not done that, but the capacity exists. Now it's easy. You can pull with Android, you can pull all the other sensors in. So you can luminescence sampling. I said light or dark, so you can maybe see whether the person was sleeping or not at night, but time should also do it. And then we have a really cool feature that I'm kind of proud of that is a baseline speech sample where the person can say something into a microphone and the participant, and that can be just a little brief statement, or there's these standardized paragraphs that contain all English phonemes. And this is important if we want to do later on, if we want to do like idiosyncratic speaker recognition through automatic speech recognition. But it's also really helpful for the coders because sometimes the challenge is who is actually the participant among all the people talking. And oftentimes you get it through redundancy when the person in repeated sound files, you hear the same voice over and over again. But if you have a speech sample, even though this is kind of more of a lab-based, a kind of a sterile into the mic speech sample, I think this is helpful. And then we've never had to use it, but now we do this robust sampling mode. And Kelly found out that that is the saving grace for the ear app at the moment. It turns out that getting timing right is really difficult in Android. Getting exact timing right. I don't know whether you had similar experiences, Liz. So the timing algorithm is the most fragile one. And so we build in a robust sampling mode where the timing is maybe not quite as exact, but it works. And so at the moment, this app is 3 years old, and we have not updated it. We are planning on updating it. It will happen probably later in the fall. But at the moment, it does work, I believe, in all the essential functionalities if you switch that robust sampling mode on. If you don't, then there's certain, I think you have some skipped recordings. Kelly showed me that, where sometimes it just doesn't record, and then you have some recordings that come more closely than they should. So all of these strange things. So what are challenges for e-researchers? There's really 3 major challenges. Well, the first one I just put there because not everybody has big grants, but there's cost, there's labor intensity, and there's legal and ethical consideration. The cost is actually really not that bad. I mean, you need a phone. At the moment, we recommend the Nokia 4.2 phone with Android 10. That's about $120 unlocked. And you probably can do with a battery of 20 phones or 25 or 30 phones. I think you can get quite far if you stagger your recruitment in a certain way. You need a protective case, ideally with a belt clip. And you need a micro SD card that you plug in order to have enough memory to save things. So you're really in for $150. And allow me that comparison. That's about 20 minutes of brain imaging. And so it's really actually not a very costly method. Labor intensity, that's where the cost comes in. And Karen said, well, we couldn't really afford coding 5 years. And it is unfortunately, like, it is so tempting to say, oh, wow, this is a cool method. Let's do this. Let's do an ear study. But in that sense, keep in mind, it's not that different from other observational methods where observational methods, you need to show intercode reliability. So you need to code with 2 coders and you need, to go over all of them. It takes forever. And we are just coming out of a study, a really important study on adolescent social life after being hospitalized for suicidal thought and behavior. And it's hard to believe, but we coded for 5 years. And so how labor intensive is it? I think so. Here you see this is kind of the basic grid of how we do this. Each line is a sound file. And you see there's the file name, there's the time, and then there's the transcript that coders need to produce. And there's all these codings like is where somebody else is talking and so on. But in all of that, I think it's really clear that the transcription takes most of the time and also listening to empty files. So that is very important. So you could make ear research so much more efficient if you just did away with that nasty transcription. Sadly, my heart would bleed because in many ways, the spontaneous conversations that you get are also the most interesting. So that's a challenge that we need to face. And so how can we face this challenge? And one of the examples is the one that Karen mentioned in her initial talk, that if we could only identify sound files with speech, we would effectively save, it depends, like 2/3, half of the time, because the base rate of conversation, it varies a little bit by population and by sample, but it's between, we spend about 1/3 to maybe half of the time in conversation. So 2/3 of the sound files are basically empty with a few sounds here or there. And if we could hone in on those that contain speech, it would be really helpful. And I think there is now very good methods. So Karen was the first one to pioneer that. So she used Adobe Audition to display the voice, the waveform of the sound file. And from that, researchers could very accurately and pretty efficiently see what's going on in the sound files, because speech has a very recognizable shape. And you can also do this fully automatic with voice activity detection, and that's what we've been trying. But ironically, there you really have a problem, because if you take a standard voice activity detector, they are so sensitive. I mean, you see it in Zoom. If you just breathe, probably the frame goes yellow, right? And so they're trained to be highly sensitive. They're really not voice activity detectors, they're noise activity detectors. And so you get a tremendous number of false positives with those. It still saves you the time to kind of weed out all the complete silence. And we talked about distinguishing complete silence, likely uncompliance and sleeping, from sound files that have some ambient sounds, but are not just a flatliner, right? And so I think that could be helpful for that. And for detecting speech, we're now exploring foreground speech detection, which is kind of in audio signal processing, the latest frontier, that we distinguish in a group of speakers or in a group of voices, who is kind of the speaker in the foreground. And since the mic is closest to the participant, that actually has been so far the most promising approach for detecting or for mimicking our in-conversation coding. It's also still very computationally intensive, but hopefully that'll be faster. And then this, I'm actually very happy to put this on this slide right now. I didn't have this in other versions, in other workshops. Guess what? I mean, conceptually at least, I mean, Penny Baker, my mentor, had to, why don't you run this to speech to text? And we had done that. And it had been abysmal. It had been really, really, really bad for much of the time. But I don't know whether it was the pandemic, because of course, Zoom power transcription, I mean, somehow transcription, speech to text has become so much better lately. And so we tried it out again. And if that works, if we can run the sound files through automatic speech to text, there's still some things to consider. But we can paste the rough transcript in, and then the person can just clean it, right? Or, I mean, maybe down the road we don't even have to clean it anymore. So here's just one example. So this is our human transcript. I have to confess, I picked a phone call where there's not too much going on and it was relatively clear sound. I did that because I was horribly skeptical. And so here the participant says on the phone, hello, hello. Well, this time it was fun. There were lots of interesting talks. Plus I got $20. They're going to pay me a whole $100. So I said, okay, good, I'll take it. And I got the best news ever. I was tested when I went for my physical. I said, test me for that APOE4 allele, the one that causes Alzheimer's. I mean, there are other things that cause it, but that's what, and then this name is de-identified, I do not have it. And so this is actually, that happens to be kind of a nice sound also for an aging workshop. And so what happens when we throw Google at that? And this is what Google does out of it. Without any pre-processing, I just did that. Hello, hello. Well, this time it was fun. This time it was fun. I've heard lots of interesting tasks. Plus, I got $20. They're going to pay me $100. So I said, okay, good, I'll take it. And I got the best news ever. I was tested. When I went for my physical, I said, test me for that APO for a little. So there's a little inaccuracy, which makes sense. That allele is a little. The one that causes Alzheimer, I mean, there are other things that caused it, but they know that does, and that's what, well, the de-identification didn't work so well here with I do not have it. I do not have. So you see, it is surprisingly good. We did this 5 years ago and it was gibberish. So we're now thinking about using this systematically. There's things to consider because you promise, I mean, if you upload things in the cloud, it becomes problematic. So I tried Otter AI as well. That's the one that powers Zoom, and it's actually fabulous. Otter AI is even better, I believe, than Google Speech to Text. But for Otter AI, there's no way that the data doesn't get sucked into their big database for algorithm optimization, whereas Google Speech to Text allows you need to pay a little more, but if you pay a little more, then the data will remain private and will not become part of the Google database. And I think that's important for things like this. So you can actually run this from your local server, engage the speech to text, and the file never goes. It probably goes for a few seconds into the cloud, but never stays there. It's never stored there. What else can you do? I think it's when you sit down and you have these ambient sounds, there's so many things that you would like to code for. I think it's tempting to come up with that long list of coding, and sometimes less is more. Focus on those categories that are really central to your coding. Why? Because the audio recordings are going to be around, and once you have pre-tagged them with conversations and things like that, it becomes much more efficient, say in round 2, to say, well, now within the conversations, I want to code another aspect. So you can just right away go to only those sound files that were tagged as conversations. Develop intuitive and specific coding categories. That is super important. I mean, we've done the whole thing with double coding right now. It would be so much more efficient if you could do it with single codings. And maybe you can. If it's just about whether the participant is talking or laughing, or there's a TV in the background, or whether there's music in the background, you don't need 2 coders for that. You get intercoder reliabilities in the high 90s, and it's a complete waste of in this case, human labor and lifetime, researchers' time. On the other hand, if you want to code things such as compassion, expression of compassion, or social support, all the things that psychologists, of course, would love to measure, but those are much fuzzier categories. And so where are the boundaries of those categories? What is just the person doing something versus the person providing practical support? And it gets really tricky. And so that's something to consider. Then, of course, you need double codings and who knows what else to get things to become reliable. And invest in coder training and the coders. So wherever we can, we really try to pay our coders because it makes a big difference. We do this, of course, we can only do it when we have a grant. I don't know how much I need to say about the legal and ethical implications. Ambient sound sampling, of course, is really sensitive. There's many things that the person may not want to have recorded. And I think for that, at least legally, there is no problem because the participants sign informed consent. There is also no problem because participants have that privacy button in order to give them privacy going forward. And there should also be no problem because in all studies where we can, we provide participants a chance to review the recordings and delete anything that they want to have deleted. Granted, not everybody can take the time and wants to take the time. And sometimes people know there's some stuff on that's probably embarrassing, but they say, well, this is for science, right? And this is what I did. And so I think there's still a lot of responsibility on behalf of the researcher to treat these data with care because it is not intended that we sneak into the private life of participants, but you may find people in the bathroom or you may find people in other activities that would be embarrassing to them. And so but that's sensitive research. I mean, that happens in other areas as well. So we just know there's professional ways to deal with that.
I have a question.
Yeah.
Have you ever had dyads both agree to participate so that you can code out both of their data?
Yes.
Like for your...
Yes, we've done that. That was actually my first grant as a faculty with a breast cancer study. And the person who has mostly published from that is Megan Robbins. And there was 50 couples where one person was diagnosed with breast cancer. Also, right now, just a month ago, Dave Sabara, a colleague of mine, and Jessica Andros Hanna, who just actually very quickly joined here, sadly during lunch break because she had the Arizona hour wrong. They have a grant where they will do another couple study. So yes, it is possible, and there's extra considerations because on some level, from a practical perspective, I mean, do you sync the devices in time? Do you not sync them in time? If you don't sync them in time, you get twice as much information. But on some other level, you really want to sync them so that you have fully commensurate information, right? But did you have a specific question about an aspect of doing a dyadic study?
No, I just wondered about the consent process. That if you had both people consent, then you could code,
Oh, I see.
Data. I know with Karen, we can only code the one that consented, but
yes, absolutely. That's a good point. Yeah. Yes. So the more people in the person social network consent, the more you can actually do with the data. So we are only allowed to transcribe the person who consented, and that's a bit of an issue for speech to text because we need to discard that, of course. But if you have a partner also, then you can transcribe that as well. Absolutely. That's a good point.
Great. Thank you.
So the problem mostly comes around these conversation partners that the person is talking to that are not signing a consent form. And there the big question is the expectation of privacy. And there's different laws that apply for that. Long story short, we have now like one party consent laws where it's legal if only one person knows about the recording, and two party where it's legal only if all parties consent. So the legality is key, but ethically, I think we've always handled it that it is important that every party must be aware of that, because otherwise it's just not ethical. And so we've worked out guidelines or principles that protect the participant in their privacy and the bystanders and conversation partners in their bystanders. And with that, we've actually gotten approval in California, which is at both at UCLA and at UC Riverside, and that's a two-party. California has two-party consent law. I should say, and just we are asked to say also the things that don't work so well. Here in this country, in this beautiful country, and I am German, you cannot do ear research. I tried it over and over again. German law is two-party consent law, and there's different ways to interpret two-party consent law, and they have a very strict interpretation that you can, like, it's all about passive consent, with a passive, how you obtain passive consent. And they say there's no way that you would need written consent from everybody that can be recorded. And so it's just, that's a break.
I just want to pipe in and say that Matthias has a number of really good chapters and papers if you look up what he's published on doing this research ethically. And it's really helpful. It's really helpful to cite those in your IRB as well. So.
Thank you, Karen. I mean, it was always from the very, I mean, we didn't go into this mindlessly. We knew that it's kind of, well, at the time we did it in the late last century, it was kind of crazy, if you want, so to just eavesdrop. So we were very mindful, how can we do this in a way to protect everybody that's involved? And I think the biggest thing to me is that participants, is the compliance we get and the feedback we get, that participants in the way we handle it don't mind. And so how do we do it? Well, first of all, we record only a small fraction of the time. It's like 5% of the time our sampling, 95% are private in the first place. The snippets are very short. It's like 30-second snippets. I think we can go shorter, but that's a different, I'll talk about that later. And they're taken out of context, to the sadness of all the qualitative researchers. So yes, you get enough information to know whether the person is talking, whether it's a phone call, whether it's a professional conversation or a leisurely conversation. You probably can identify the conversation partner, but the bigger context, you just don't know. This is really important. The ear method, I think, is ethical and in many places legal, to the extent that you can ensure that other people notice about their potential of being recorded and readily notice. So we've always put these warning triangles on the devices so that people know there's a chance of being recorded. In California, you need to also have a little button that says this conversation may be recorded. And that way, the idea is you obtain passive consent. Just like in a phone call, it just says this conversation may be recorded for quality assurance purposes, and you don't have to press a button, you don't have to sign anything. The fact that you hear it, and they can assume that you heard that, and that you decide to speak, is passive consent. In many states, that is how we've worked with the IRB to work this out. Participants must have a ready chance to see that. Again, in Germany, that was not sufficient. I believe at Penn State, it also in the state of Pennsylvania, it also might not be sufficient. We always provide participants with an opportunity to review and delete. They actually review quite a bit and they enjoy that. They delete very few sound files. And the sound files delete are very idiosyncratic ones that we don't ask, but this person volunteered a church service, or the person didn't like us to hear them singing. And so but it's very few sound files. During the coding phase, we remove identifying information. And also, initially, we needed to actively apply for that, but now the NIH issues that, at least with the grant, automatically. All of our data is protected by a certificate of confidentiality, so that the data is protected against forced third-party disclosure. So the data cannot be subpoenaed. So far about it. Is there any question around that? The challenges? Let's go to, I don't even know how it, oh shoot, we're almost done. Okay. So I have 1 minute left, is that true?
Yeah, about a minute, but we're all engaged.
Let's go very quick. Let's go very quick. I just wanted to do an example of coding. So here are some sound files. So this is one of those coding sheets that we use, and we're gonna do, and if it's just 2 sound files, it's also fine. So I've prepped this a little bit. I've pasted the transcript already in there. But you're going to be a coder right now in an aging study, and you're going to hear a person. This is the first sound file.
Oh! Ooh.
Okay, that was it. So here are the coding categories. These are just some that we selected. You can have others, of course. Is this sound file interesting? This is just purely for interesting purpose, for internal purposes. Was there any problem, such as a suspicion the person is not wearing it? No. Was the sound file about the ear? Did they talk about the ear? No. Was the person alone? Yes. The person was with themselves, and the TV was on and laughing. Done. Okay. Simple, easy. Next sound file.
Yeah. Yeah, I pulled out my artistic.
Good.
I'm starting
Oh,
small.
nice. Well, you'll have to see some of the things my friend Jill does. She's not very social, so she probably won't come to my party. Can I come in?
Yeah, we do.
Thanks.
So you enjoyed meeting,
Oh my God, is he a talker?
isn't he?
He's like me.
Richard?
Yeah. Fabulous.
So you see already, it's actually not always easy to figure out who the participant is. I guess in this case, our coders knew it, but it's clear there's a group of people there. The participant is, I guess the best guess we have is with friends. Socializing, we define as kind of going out for a drink or dinner or stuff. So we wouldn't count it, but it's kind of borderline. That could count as socializing as well. And again, the person was laughing, which is actually very nice. So, and you get a good flavor of it. It was a pretty positive mood. It was a social gathering with friends. And then
So much builder beige in my life.
Yeah. What is this color? What's it called?
I
What would you
don't-
call it?
I'd have
Putty?
to look it up.
Putty,
Yeah,
maybe?
I don't know. Yeah, I'd have to
Putty?
look it up. It had a desert name to it.
Desert name, did it?
Yeah.
I like it a lot.
But
I
anytime-
love these windows, what you
Yeah.
do. That's fabulous.
And those solar blinds are great.
Boy, I'll say.
They really block the heat out. I
I'll
mean,
see.
it does get toasty in here in the afternoon, but what are you going to do? They all.
so this was a study in Tucson. And you see, so again, in terms of the coding, this is pretty straightforward. Person is with a group, the same group of people. These are, again, the friends. And there was actually, again, the builder beige was a laugh there. But you see already, this is what I mean with protecting privacy. You get a very good sense of what is going on psychologically in this conversation, what characterizes this conversation. This is not an argument. This is not a professional. This is a very relaxed, positive, affect-infused conversation. But nevertheless, you don't really know who is there, what really the purpose is. So by taking these 30 seconds, it kind of cuts it out and protects privacy. I don't know how.
Schedule, you're an institution, and you feel institutionalized. And people, and I've discovered from my own experience, people at that age who are in that situation say, I'm not looking for safety. In fact, I'm looking to be myself. If I wear shoes and I slip, here's the area. Those places, they're not selling to the parents, they're selling to the adult children. One person explained to me that I interviewed for the book.
So this is a good case of alone time. This is not a flatliner in a sound wave. The person is alone, obviously in a car in transit. You hear that very clearly. And yeah, that's actually everything. Later on in the other sound files, it's kind of nice. They go out in a bar and there's music in the background. And so it's just, but I think for the purpose of, this serves the purpose of kind of illustrating how you go about this coding. But you can see the sound files really have a rich flavor, and there's so much we don't even capture in our zeros and ones, right? So our research assistant once made the sign here like it's a 1, because we typically just code in a binary way, is the behavior present or absent. But there's so much between the 0 and the 1 that we don't really capture. I think with that, I mean, there's other things we can talk about, but with that, I've covered pretty much the most important parts. And I wanted to just thank Karen and the organizers for that. I want to thank the participants who allowed us to even present those sound files here for training purposes, and everybody in the NOSI, in the Naturalistic Observation of Social Interaction Lab, and all the collaborators, lots and lots of collaborators that have been instrumental to this research. So thank you very much.
Thank you, Matthias. That was wonderful. I'm going to open it up to questions for people. That was wonderful. There's a lot of applause going on. One thing that I'm wondering, Matthias, do you use computerized software? I know the Luke, for example, or do you use any linguistic software to analyze your data, or is it all coded?
No, we always have these two sources. So we have the behavioral codings and we have the transcripts. And the transcripts, born and raised in Luke, I just use Luke, even though the world has advanced much beyond that. And you can, of course. So I think there's these two major sources that you have. Is the transcripts. They're super rich and you can do highly advanced linguistic analysis. And there's the behavior counts, the behavior codings. We typically focus on both sources. It may, I mean, if you ask where the future lies, I now think it may be easier to automate, and I wouldn't have said this a few years ago, the linguistic analysis. I mean, you can now see a system that detects interactions and then runs speech to text and runs Luke or whatever over it and has it right there. I think the behavioral coding, whether the person is socializing or whether this is who they're talking to, and from a signal processing standpoint, is so much harder. So I think the future of that we're not going to see super quickly automated.
May I ask you, what's Luke when you said Luke?
It's a software. It's called Linguistic Inquiry and Word Count. And
okay.
It's a pretty strange acronym. It's a text analysis, a word count-based text analysis software that was developed at UT Austin by James Pennebaker and has been very popular, mostly in psychology. I think in sociology, there's other programs that dominate the scientific market, if you want to.
Yeah, it's interesting how, I know that's a different kind of topic, how these things vary, by discipline. Mm-hmm. Yeah.
There are also linguistic softwares that'll code your sound waves too that you can use. I haven't used them, and I don't know that have you used them, Matthias?
You mean like various detection of so we've had this project, there's Google Audio Set. Google created a hand annotated taxonomy of a bunch of behaviors from 10-second clips. And like dog barks, cat meows, funny enough, all the things that Google really wants to detect in YouTube clips through searches. And so I think you can, or gunshots, or like very specific sound waves. We've not done that. We have focused mostly on, my goal for the moment is that we can create an automatic algorithm, because we know that the amount of time that a person spends in conversations is such an important variable. I mean, that of course it matters what they talk about. Of course it matters how they talk. Of course it matters who they talk about. But in so many studies, I was surprised how strongly this pretty simple metric of amount of time in conversation correlates with meaningful things. That if we could automate that, I think that would be good. And then the speech to text, if we truly get the language profile of the word use, I mean, we just show that the complex, use of complex words, use of numbers and use of abstract words correlates with working memory. So if we can do this automatically, wow, actually that would be a huge leap forward.
You want to say something, Karen? Go for it.
Oh, the other thing I keep thinking about is, this is kind of a personal detail, but I wear hearing aids. And they detect constantly the foreground, the background, whether it's a voice or not a voice. And they're really weird with music. So it seems like there's a lot of processing going on there. Have you talked to audiologists or audiology engineers? Or?
Yes, my wannabe best friend is Sri Narayanan at USC, who is kind of a high-end audio signal processing person, and we have worked with him. And it's exactly that. It's funny, I don't know much about the hearing aid situation, but I can imagine that it's exactly the same problem. Because what you need to do is you need to separate relevant speech, your speech, but also your conversation part of speech, from background music, music like singing, TV speech, kids babbling in the background, other people in the coffee shop babbling, that needs to be suppressed, but the conversation needs to be enhanced. And that is in some way exactly that separation task that we need to get from the audio. So it is, I mean, audio signal, like visual signal processing was on a like, have made huge progress, I would say, like in the last 20 years. Audio signal processing is a hot field right now. I mean, I'm just going to be the end benefactor of that in some way, but it's a really, really exciting field with lots of progress for hearing aids, for searching through. I mean, that's where a lot of power comes. Like you can search pictures for mountains or Easter eggs or whatever you want in Google, right? But you couldn't search YouTube clips for children singing or dog barking. And it's a huge market, of course, for Google. So I think, and same thing, of course, with Amazon Alexa and all of the home audio devices. And Amazon Halo is now, they have a wearable device, but they focus more on kind of funny enough, they focus on what I wouldn't focus on. So they have this band and they want to know my mood through my speech. And that's fine, but I'd much rather know the environment. So I see it more as an environmental sensor. They see it more as a person-centered kind of speech and mood mostly sensor.
Well, Matthias, that was really fabulous. You know, I love your app and it's just so informative. We've learned so much about the social world, the cognitive world, the medical world from your observations. And, you know, so, and I want to thank all of the panelists. I have to say, I've learned so much and been so inspired today. And I want to thank you all for coming. And this was our first workshop with the Center on Aging and Population Sciences. And we're really grateful to have had this opportunity to be with you all today and learn so much.